to start, I will welcome Mr. Pritam Mother from ITU and Miss Anna Paula from UNIDO to give the opening remarks. And for Mr. Pritam Mother, he's the head of Emerging Technology Division at the ITU. So floor yours.
Thank you, Jin, and welcome everyone. So, this workshop is a collaboration between the ITU and a valuable partner, UNIDO. And since the inception, the two of us have been working together on this very important topic. So this reflects our commitment on using AI for sustainable and inclusive industrial development. Here, I'd really like to acknowledge Professor Wang from the KTH Royal Institute of Technology for his expertise and vision in organizing the AI for Manufacturing webinar track since its inception in September 2022. And I recall being involved in the first set of conversations on kicking this off, and Professor's enthusiasm and leadership on this topic, where we've had 13 insightful webinars and a machine learning workshop also at the last year's 2023 summit. His efforts have obviously enriched our understanding, set the stage for this important discussion. So today's workshop will explore the impact and versatility of large language models and also vision language models, VLMs, across different sectors, focusing particularly on manufacturing. We'll move from theory to practical applications, showing how these technologies address global challenges such as climate change and revolutionizing manufacturing processes. We'll discuss how LLMs and VLMs enhance human-machine collaboration, aiming to give participants a better understanding of these technologies. The goal is not just to inform, but also to inspire, showing how AI can revolutionize manufacturing, improving efficiency, and promoting sustainable development. So AI integration and manufacturing presents both challenges and opportunities, requiring us to consider the ethical implication, workforce challenges, workforce changes, and environmental sustainability. Today, we are called to navigate this landscape with ambition and responsibility, envisioning a future where AI drives innovation and inclusivity. So our speakers and panelists chosen for their expertise will guide us through this exploration. So let me, in closing, encourage you to fully engage in this discussion today, share your insights, and contribute to this important dialogue. Thank you very much again.
Thank you.
Thank you, Pritam. Good afternoon, esteemed colleagues, distinguished guests and participants. It is my pleasure to be with you in this workshop on large language models from sector applications to implications for human-machine collaboration manufacturing, co-organized by UNIDO and ITU. Today's workshop addresses a critical area of innovation that is transforming industries globally. Large language models and vision language models are not only advancing technology boundaries, but also redefining the dynamics of human-machine collaboration in manufacturing. At UNIDO, we are dedicated to promoting inclusive and sustainable industrial development. Our focus on digitalization and AI strategies is central to this mission. ITU, with its expertise in telecommunications and digital innovation, plays a crucial role in advancing global standards and a collaboration in AI technologies. According to recent studies by McKinsey, AI applications in manufacturing could contribute significantly to global economic growth, potentially adding up to $3.5 trillion annually by 2030. This highlights the enormous potentials for AI to revolutionize the manufacturing sector, creating new opportunities and addressing long-standing challenges. UNIDO's initiatives, such as the Global Alliance on AI for Industry and Manufacture, AIM Global, are fundamental in encouraging collaboration and driving the adoption of AI technologies in industry. ITU continues to support international cooperation and policy development to ensure that AI benefits all sectors of society. Today's discussions will explore the practical implications and applications of LLMs and VLMs, the benefits they bring, and the challenges we must overcome to fully realize their potential. I encourage all participants to engage actively, share insights, and collaborate to advance our understanding and implementation of these transformative technologies. Thank you for your attention and for being a part of this important dialogue. I look forward to the productive discussions and innovative ideas that will emerge from today's workshop. I would like to extend my gratitude to the organizers, speakers, and participants for their dedication and contribution to this workshop. Thank you.
Thank you, Anna, Paula, and thank you, Britam. Now it's my honor to introduce the moderator of our session, Professor Li Hui Wang from the KTH Royal Institute of Technology. Professor Wang is a distinguished academic and researcher, holding the position of professor and also chair of sustainable manufacturing at KTH Royal Institute of Technology, Sweden. As the director of the Center of Excellence in Production Research and the former president of the North America Manufacturing Research Institution of Society of Manufacturing Engineers, his work has significantly influenced the field of smart manufacturing. And Professor Wang's research spans real-time monitoring and control, human-robot collaboration, and sustainable product systems, contributing over 600 scientific articles and receiving multiple international awards for his grand breakthrough research. So let's welcome Professor Wang to moderate. Thanks.
Thank you, Jin. As introduced, I will be the moderator for today's workshop. We have a fully packed room and a packed agenda for today. We also have online participants. So welcome everyone to this session. As you can see on the slides, we have 7 keynote presenters. That's a part 1. And follow the part 1, we also have a panel discussion. So it's a 4 hours workshop. Each presenter, the keynote presenter, has 25 minutes. Please reserve your time for questions and answers as well. So let me firstly introduce our first speaker. The first speaker is Mr. Martin Wallisch. He works for the United Nations on Peace Processes, National Dialogue, and Conflict Prevention, and is an affiliated lecturer at the Center for Peace Mediation and the Institute for Conflict Management at the European University, Vienna. He holds a PhD in international law and an MA in mediation. His topic today is leveraging AI diplomacy and peace building.
Yeah, thanks so much for
Whenever
having me.
you are ready.
Yeah, just getting the technology ready. I'm going to do the standing. That's okay.
Yes, hopefully the online audience can see the camera is over there.
And I think you're going to share the screen, right, of the presentation. We're going to give some illustration to my presentation. Well, thanks so much for having me. Thanks to ITU for organizing this. Full disclosure, I'm not an expert on manufacturing. I work in the Department of Political and Peace Building Affairs. So we are busy with manufacturing peace agreements, national dialogues, but maybe the idea was to give some comparative overview about how we use LLMs, AI to advance peace processes. When you think about it and you work in the manufacturing industry, you might face difficulties in the company, for instance, right? Where you have consumers that are unhappy and often peace sits in different pockets. It doesn't need to be this high level, Syria, Ukraine kind of thinking. It can be in different parts of society. Now, what I'm gonna run you through is how we use AI for diplomacy and peace building in particular, and I'm gonna draw from some very concrete examples of what we've done over the last years. Yeah. Now, our work spins around innovation in the context of diplomacy and basically responds to new conflict realities. While in the past we saw states moving, towards each other or away from each other. Now we, basically look at a new reality where climate change plays a greater role. The Secretary General of the United Nations has, called on all of us to pay attention to the World Wide Web, non-state actors. And I think kind of this meeting here is testimonial to kind of the new landscape where technology is very present. And that means for us that we need to draw from new technologies and new affordances in the context of science to move ahead with our diplomatic efforts. And I'm saying that because I started in the UN over 10 years ago, and when I talked about machine learning at the time, I would have been ridiculed among diplomats in bringing in technology perspectives. And my favorite example is a paper written by the Special Political Unit of the Secretary General in 1982, so 1982, which was called machine learning to predict the arms race between the USSR and the United States of America. And you find that paper, as I did my PhD, in the UN library. It's a declassified paper. So there has been a paper on machine learning published, or at least kind of stored in the UN library in 1982. So just to say, we know that this has been around and this has been relevant also for us in the social science context. But I might be an outsider here. Many of you probably have an engineering or computer science degree, which I don't. Now, I think the quintet has created an interesting framework for all of us in the UN family. We just had the UN 2.0 week, and we're getting more member states on board. Some of the futures ahead of us. Wanted to mention that here as well, because it kind of calls upon all of us to use data, innovation, digital transformation to bring forward the organization. So it's not just left for the good technicians in ITU or elsewhere, but also us, working in the secretariat and working with the finance and these techniques. And what I think is interesting about the quintet of change is, and I hope we can speak about this a bit, is the human aspect of technology, because it's not just a tool that we make available, but it transforms how societies work together, right? So that's why I feel very strongly about behavioral science. And just to put another week on your radar, in a week from now, starting on the 6th of June, we are having the UN Behavioral Science Week, where we look at human-machine interaction, how is AI reforming or transforming societies, dependency of technologies, but also the whole issue about mis and disinformation, deepfakes, and how this is reshaping kind of complete dynamics. So I wanted to put a pin on that. Now, when we think about LLMs, we attack this topic. We have a range of themes in our innovation team in DPPA. But when it comes to LLMs, we'll look at this with regard to three thematic areas at the moment. One is how can we use LLMs to advance digital dialogues? I say a few more words about that. That means basically interactions of UN officials with peace constituencies, aka you, the people, so those who are not in charge of making decisions, in order to drive inclusive processes, right? Because we believe that inclusivity leads to more lasting peace, right? Second part is the whole issue around digital listening, where in the past we had something which some called social media, which is not so social anymore, not so much media anymore. It's more kind of feels like entertainment places, but it's going through a reform, right? And we just had other sessions on the metaverse, like social media is redefined. So how do we use it as a signal, right, on the political end to learn what the people think, right? In comparison to mainstream media sources, right? Reading the BBC and listening to CNN gives you a certain picture of Gaza at the moment. And then, there are other signals. So how do we multiply the signals we get? And that's where LLMs are extremely helpful when it comes to summarization or translation, especially with regard to low resource languages, right? Where we don't have a necessarily translator right here, or not the capacity, right? Because we have how many people do we have that are fluently in Arabic, Russian, and the other official languages. And then the last part is kind of a crossover of methods, digital engagement. I say a few words about this in the very end. I'm a VR maker and producer as well in the UN, and I feel very passionate about kind of NPCs powered by AI, interactive solutions. And we have seen some quite kind of extraordinary kind of solutions there, using Unreal Engine with OpenAI, do this in 5 minutes. Some of you might have looked at meta-humans, very realistic human. We looked at avatars, and a lot of affordability in kind of creating new spaces, not just for the peace world, but also for the manufacturing work, right? Where you want to give people an idea for, well, how a space looks like, how an end product looks like, how you interact with the product, how you can stress test that. And we were lucky with the support of the Norwegians 2 years ago, we had the president in the Security Council to bring in VR to the Security Council chamber, and that has been a practice ever since. VR has been around in the UN system for much longer, I'm totally aware, but it was the first time that we managed to get this into the chamber, which is kind of this holy chamber of, walnut wood tables and the water pitcher, which is the same from 1953, right? It's the same water pitcher. We have a collection of them in the Secretariat, so getting new things in is a struggle. And I'm saying that because anything we come up here with new ideas, how will that stick with a very risk-averse and complex organization that we are, right? Where we have different mentalities and kind of cultures that have different beliefs in technology. I'll give you a quick anecdote. When we did the screen the council on VR, which was just 360 immersive footage, there were some member states, I'm not going to reveal the identities, that were saying, am I going to be brainwashed by this immersive device? And we said, well, we went through procurement and it's safe, etc. So just to say that there's a lot of cultural resistance, right? We have to deal with. Would love us to talk about it. It goes back to the human aspect of all of that, which is a technical exercise. Now, let me zoom in on digital dialogues. So again, how do we get people to agree on what's good for society, right? And that's easier said than actually done. So what are the usual modalities? Usually we have large conferences like here where we bring people together that make decisions for everybody, for the common good, right? Libya, a good example, or to a certain extent, we had 75 delegates making decisions for 7 million people, right? That was the Libyan Political Dialogue Forum. And you can make your own judgment where things stand in that regard. Give you a second example, much earlier, a dialogue where I worked in Yemen for 2 years on the national dialogue, where we had really a kind of on paper a supreme example of how an inclusive process should look like, with over 500 delegates, women in the room, civil society, youth delegates, and so forth, representing 33 million, right? So that's the usual modus vivendi. The problem is, like in this room, there's never space for everybody, like here, right now, right? There's only space, there are only some seats, and you need to make decisions for everybody. So the challenge is to us, how do we really create inclusive processes, right? Now you can enlarge the circle, and in Yemen it was the case. So we just rented, the UN rented with UNOPS, the Mövenpick Hotel, which is the largest hotel in Sana'a, right? It's a massive, big, those of us who have been to Mövenpick Hotel, they're same big hallways like ships, So you fit in 700, 800 people plus. They do big Yemeni weddings there and also national dialogues, but you don't fit in 33 million people, right? And everybody consumes it differently. So how do we address this, and how can we use new technologies to get scale, size, right? But also intimacy and personal touch. That's the challenge we have been looking at the last years. And I'm going to give you an insight on how we've done this using LLMs and AI. Now, the typical modi are the dialogue forums that I mentioned, then focus groups, a bit smaller than that, usually 30, an hour. And the good thing about focus group is you get paid for it, because otherwise, why wouldn't we be in there? You create a panel, you have some representation. I'm not going to hand out Amazon vouchers, but there is a free coffee out there. So that might be an incentive for you to be here. And the beauty of focus group is that you hear the answers of others, so you can form an opinion. It's called deliberation, right? Deliberation is a concept where there's a process of forming an opinion. Then there are surveys. What surveys you get scale? You have statistical relevance when you have 2,000, 20 questions, but they're very expensive. They range at the moment in a conflict zone between $80,000, that's Haiti, to $250,000, that's Yemen, right? Because you really send a polling company into an active war zone? The answer is yes. Some member states do this on a monthly basis. But Yemen is $250,000 for a sample of 2,020 questions. We can't afford that as a Department of Peace and Affairs, because member states don't give us the resources, unfortunately. So we need to find digital ways, right, to get scale, but also interactivity, and that's where digital dialogues come in. I'll say a few more words about that. Digital dialogues for us is a menu of options that includes peer-to-peer conversations on WhatsApp, things where you organize your family to solve a dispute about what to get for Christmas or whether or not to invite your uncle. Story of my life. Or, again, I come back to social media, the YouTube, the TikTok, the now X channels. I don't know when I was on X the last time, of contact here if you're from Russia or other places, WeChat and so forth. The problem is moderation, right? So on YouTube, you get scale, comments floating in, but there's no moderation. The best thing is that you get the toxicity out, so that the insulting language is filtered out, but you can get no moderation in there. It's kind of how do you manage 200 comments coming in, you add your like. But as a moderator, very hard to steer the deliberation process, like forming an opinion. People just shouting at each other, right? And that's why we have seen kind of some move towards peer-to-peer groups. So WhatsApp, Signal, Telegram, you're part of that. If you are running a political process, you don't want to let your uncle know that he's not invited, so you have a separate Signal group on that. But good luck moderating that or kind of distilling from that, right? There are some APIs for Telegram, we pull this out, but it's not a neat workflow. So we need to create a tool that allows us to get scale and then also a representation visualized quickly. I'll show you how that looks like in a second. The reality is that we are looking at hybrid processes. So Libya is a good example where we have some kind of online presence, like here, in person and online, because the truth is, at least I speak for myself, I don't want to be just kept in a Zoom call or MS Team call, right? I want to have in-person interactions, right? Because there's different type of energy, a different level of trust, curiosity, errors, 100%. One of the 7 presentations won't open in the beginning, gives us all a moment to breathe. So we're looking at hybrid ways, how AI comes in for peace processes. We were lucky with Stephanie Williams, who was the acting special rep of the Secretary General Libya at the time, who took a chance and really brought in machine learning AI even before OpenAI had launched, into the peace process to use new technology to reach out to peace constituencies. Now, how did that work? It worked the following way. They even had an open call out on Twitter, at the time Twitter. And keep in mind, Libya, people love the UN. So most places I worked in, unmarked vehicle, I would never have a pin on because I'm not going to be a one target, So, but there are some places in the world like Colombia, Cyprus, and also Libya where the UN is actually welcome, not like the Middle East where you would, be suicidal when you have a UN flag. That meant with a post within 24 hours, you had over 2,000 Libyan youth or self-identified youth signing up and showing up for a dialogue which was happening on a platform where we use the power of AI to summarize quickly the results. So you get the instant summarization and visualization, right? And on top of that, segmentation. So you ask onboarding questions, you ask in the survey, how old are you? Self-identified, always be 18, gender, education, location, political preferences, and so forth. And those among us who are social scientists like me, I love segmentation because it can actually, find correlation, for instance, like what are women thinking in that context? What are the educated, self-identified educated individuals thinking and so forth? Because then we can tailor solutions that are relevant and really listen to what the crowd thinks, and that can be done at scale, again, with semantic similarities and machine learning. It's basically SurveyMonkey, all of you know SurveyMonkey, or Google Forms on steroids, right? And that's actually where the big survey companies go to. It's a $6 billion business that is not profitable, by the way. None of the companies makes money from that. They just have donations coming in from member states and companies. And kind of LLMs particular for specialized domains like political conversations, because it spins around the same issues, elections, how the security forces are doing, what social services are provided, right? Give us an opportunity to do this more or less language agnostic. We've done this in low resource languages like Arabic dialects. So here, Libyan dialect, those who speak Arabic know that it gets very nitty gritty when you speak about issues, and you would do this in your colloquial dialect, right? You wouldn't do this in modern Fusta, which is like news presenter Arabic, but in your local dialect. And I say that coming from Berlin, right? When I'm home, we speak Berlin dialect, and there are words in there that you wouldn't find in a traditional dictionary. At the time, I think the technology that we used was still a bit clunky, but nowadays, with you name the LLM, there we go. You name the LLM, it's getting better and better. For most Arabic dialects, OpenAI, Gemini works pretty well. I'm just waiting to get, the hard languages to crack where we don't have written context to train on, right? I'm thinking about, indigenous languages, but or think about Myanmar, where we have like 18 languages that are actively used, but very little text documentation. But we still need to invest into kind of, transcribing and then putting this into a model, which we have done in the context of that project as well. So we invested as the Department of Political and Peacebuilding Affairs, thanks to extra budgetary funding from donors, into 4 Arabic dialects, which are Libyan dialect, Sudanese, Iraqi, and Yemeni dialect. Yeah. So, and that's available as a resource to all of us. So that's on GitHub. We made this aware. We made this public through the Arab Language Day that we celebrate in December every year. And, want to put a finger on that because a lot of the solutions that we're thinking about when it comes to LLMs, need to be publicly available, I feel, to be challenged and also be used more broadly. In the context of Libya, that really became a series of conversations using AI, again, giving you the power of a poll, which is scale, and the intimacy of a focus group. And it kind of created momentum to bring in the unwanted voices to a conversation. So to give you an example, a lot of the conversation we're spinning about early elections, and you can imagine who wants early elections, people, and you can imagine who doesn't want early elections, those who are in power, right? Because you might lose power, so why should I have early elections? So it was a good leveraging point because those at the table would say, we don't want early elections, and people's voices made a push, and SRSG at the time, acting SRSG would say, I just talked to thousands of living youth, and they say, we should consider early elections. It's not my view, but here is an answer on that. Again, you could crack that with a survey, but it would take much longer and would be much more expensive, right? And that's where technology can really help us. Instant responses, I think tech is really brilliant because it gives us optimization with regard to processes, and then fraction of the price, right? Fraction of the price, again, between $80,000 to $250,000 for a survey where you have to wait at least 4 weeks, you're over. And just to give you some historical anecdote on this, Peace service had been done for a long, long time, started in Northern Ireland, where polls were done on a Friday and the results were published on a Sunday. Yeah, so just to say, like, kind of, now we're just revamping some kind of method with new technology that has been around for another nice anecdote here is, although we had only a technological capacity to host 2,000 people at the same time in the conversation, that has changed now, but at the time, this was 4 years ago, we had over 4 million people watching it like a football game on national television, right? Because it was live streamed on Facebook and then broadcasted on national television. So like the multiplying effect of those conversations is just very intriguing, let's put it that way. Pandemic has helped. You see people with masks, and I feel all of us working in tech on the innovation side, you know, in the past, it was only the blessed ones who got a laptop. Now everybody has a laptop in the UN system. Because of the pandemic, we don't have to force people to use SharePoint anymore. It's like a must. So I think that momentum has helped. And I wonder whether we're still in the float or we're going into this tech fatigue, right? Where people are like, please don't talk AI. And then we need to be the silence change agent, right? Maybe we have to say it is, but do it more, right? I think that's going to be an interesting time. We'll repeat it as in Haiti, Haitian Creole, which is not a standard language, right? And many other places. Now, I wanted to play a video, and I hope it plays from the internet, which gives you an idea for how this looks like from a participant perspective. And this is the story of a young Kurdish activist who participated in a dialogue we hosted in Iraq just before the elections a few years ago. So now I can be the victim of my own comment. We'll see whether that works. There are subtitles. The story of Iraq and Marwa is basically using technology to give power to the people, right? So the things I'm just going to summarize this like in my own words. One is how do you participate in a conversation that is usually left, you know, to those who are in power, like very exclusive conversation? How can we make a point that there's no excuse to say there's no more seat available, right? So we can say, hey, scale is endlessly available, right? And then second thing I think from that story is also the point that we kind of use the power for decision making. We use the evidence, right? It's not just that putting the finger in the air and driving your political narrative home, but like having evidence at hand through those surveys, through those dialogues that help make decisions. And the third part, and maybe it wasn't clear enough here, We use it as an anonymous way. So this is like a text-based conversation on your phone, like a WhatsApp conversation where you don't reveal your face, your voice, if you don't want to. That has to do with the bandwidth as well. I know the comments you will say, well, did everybody participate? Obviously not, right? You need internet access. What about remote areas? So that's why this is text-based only, right? But there are compression models with lighter models, for instance, we nudge that. It's just a question of time. Now let's look into the future. And before we do that, my favorite conundrum from the UN Secretariat, that's close to conference room number 4 in the basement of New York City. That's a picture I took around 6 months ago. I swear to God, the card is still there. And we still have colleagues, love them, that push the paper, right? Took 2 years, like 2 years ago. Last year, the fax machine got abolished in the Secretariat. And then 2 years ago, during the pandemic, they abolished the physical prints of the press releases, which was always a nice photo op with 6 languages and so forth. And they were like, we don't need it anymore. But that's UN Docs in action, 2024, right? So we want this AI part and, glory and metaverse, what have you. But the truth is, it's very hard, right? I mentioned in the beginning. So we need to build solutions. I say about this more in the bit, that kind of are responsible, responsive, and intuitive. I think that's going to be the crux for the future. Now, the opportunities are clear when you think about deliberation and peace process and how to use LLMs. Again, peace processes, even in the manufacturing world, where you have labor unions protesting, or think about a big company like Siemens, or UI, you take it, which have thousands of employees, where the leadership wants to have a conversation, right, with their people eventually. Their opportunities. One is really inclusive participation. So I'm thinking about kind of lack of literacy, right? Not everybody would be able to type the answer, but think about saying it, in one way or the other. Real-time language support, so you don't have to wait, because when you want to make a decision as a leader, you want to make a decision now or yesterday. So you need instant answers. Secure and anonymous engagement, where, yes, I know a lot of the platforms we are looking at are not safe, but we're getting there. So I'm putting a pin on that. Emotion intent. So the problem is, or the challenge is, we don't often know what we want and why. So we're verbalizing this, we code what we want, right? So we need to decode that. And there was an interesting experiment at the University of Washington ran in October last year that you might have seen in the news, where they had a group of psychologists, 20 psychologists running against ChatGPT. Anybody have seen that? No? Okay, fascinating experiment. So they had 100 patients, only a university can afford that were for 30 minutes playing a scenario, right? And expressing emotions, whether they're angry, happy, sad, depressed, name it from the wheel of emotions, Then they had 20 psychologists listening to them and noting down the emotions they recognized. 20 minutes. Attention span for me is like 15 minutes. So good luck with that workshop. Let's see how long that goes. So if you don't have a break. And then had ChatGPT doing that. And then they compared in the end. And they saw that ChatGPT was, at the time, October last year, was much better in identifying the emotions. Intrinsic biases of the psychologist, maybe, or a tall white German guy, he's probably depressed, he's depressed. Maybe I was just angry, but depressed, So cognitive biases, 20 minutes is a long time to really actively listen. Machine can listen to you endlessly. And other challenges. And then they also asked people whether they were happy with the conversation that they had with the machine or with the psychologist. And I thought, nice assumption, bless you, it's nicer to talk to a human. But guess what? 85% of that study said we were more happy to talk to the machine because we didn't feel exposed. I could really say what I think. Because how many best friends can you have that really listen to you? I have 2 in the world, but they're not always available, So that's interesting, and that's an interesting opportunity. I come to a closure, so a lot of opportunities there. What we are concerned about is not to just use LLMs and AI for the sake of it, but really build kind of responsive machines for peace processes so that solve a problem, and then make them as intuitive as possible. So you don't need coding, right? That it just fits like the real glove that you always had with you, so to say, or the shoe that you always liked. And then obviously needs some kind of responsibility, right? Many of us have talked about it. So to make sure that we don't kind of engineer the biases into the system, right? And that's a collective responsibility we have. Thanks so much for listening. Hope that got you some inspiration. Yeah, and I look forward to the conversation later. Thanks again for having me.
Thanks so much. Very interesting topic. We have 1 minute. So who wanted to raise a question for Martin? Yes, please.
Thank you, Martin, for excellent presentation in there.
I just want to ask a question about the other side of AI. So how do you deal with bots, with deepfakes, especially that you're dependent on anonymity and anonymous responses? How do you handle that? Because you mentioned like you take statistics from there, you have your surveys. Nowadays, you can have like 50,000 bots fired to this national, and how would you handle that?
Right. So we use the same barriers that you use when you try to sign up for a website, right? You click on all the bicycles you see on the picture to make, but it's getting better and better, right? And then other like, random questions on, things where you have to do access before you log into the platform. So that's one way to get it out. But indeed, when you think about coordinated inauthentic behavior for analyzing social media data, it's getting scary, right? Because most of the stuff is automated, right? You see more and more synthetic data out there, and we produce it ourselves, right? Those who work in communication, the UN, we had this last year. Remember that a whole session on synthetic data and how it helps us to spread the SDGs. It's getting like in the peace bot, right? So the SD have a dialogue bot, and so forth. So it's tough, so that's kind of, so my answer is, let's be aware and let's be kind of conscious about what's happening around us. I hope that answers. I think it was more provocation than really an answer. Thank you for that.
Thank you again. Because of time, we need to move on. Now I change the topic. I need to introduce our second speaker. By the way, there's 32 messages in Zoom, just in case there's from the online audience. We do not have time to address your questions. So let me introduce our second speaker. Beside me, Professor Lei Ren. He is a prominent professor at Beihang University, renowned for being the first recipient of a National Science Fund for distinguished young scholar in the field of industrial internet in China. His engineering contributions to industrial cloud manufacturing includes the development of the first theoretical and technical system, prototype system, and a national standard, alongside leading over 20 national projects and significantly impacting the industrial internet through his core technology. So the topic today is industrial AI towards the era of industrial foundation model. Please.
Okay, thank you. It's my pleasure to be here to give this topic. And my talk is about industrial AI towards the era of industrial foundation models. I'm Lei Ren from Beihang University. So this is the outline of my topic. As you know, now industrial digital transformation is driven by the convergence of new generation information and communication technologies involving AI, big data, 5G communication, metaverse, etc. The convergence is to improve efficiency, productivity, flexibility, and the sustainability of industry. Well, the novel characteristics of AI, new generation AI include big data, cross media, human, machine, swarm, and autonomous intelligence. The featured techniques support typical applications of AI in product lifecycle. Well, first, in research and development, AI learns previous design schemas, historical operational data, process knowledge, and customization. Thus, AI model can recommend or even automatically generate design schemas for designers. Secondly, in manufacturing phase, AI models are capable of autonomous control, process optimization, dynamic scheduling, and decision-making. And thirdly, in product test and experiments, AI model is able to automatically generate intelligent text schemas and evaluate test metrics from experiments. And fourth, Resources in manufacturing processes will be managed intelligently to further enhance production, and AI combining blockchain can be utilized for smart contract with higher privacy, security, and trustworthiness. Finally, in service and maintenance phase, AI models are capable of predictive maintenance and intelligence diagnosis for products and equipment. So in order to support aforementioned applications, industrial foundation models act as the brain for industrial intelligence, providing necessary AI capabilities to enhance efficiency, intelligence, and effectiveness in industrial applications. These intelligences will be discussed as following. Well, the first is industrial edge intelligence. Industrial edge intelligence refers to the deployment of advanced data processing and AI technologies at the edge of industrial networks, enabling real-time analysis and decision-making close to the data source. Industrial edge intelligence is crucial for enhancing efficiency, reducing latency, and improving reliability and security of industrial operations by processing data locally and autonomously. Here is one work about industrial edge intelligence in many complex equipment maintenance scenarios. A huge amount of sensor data need to be processed timely by edge devices with limited computational resource. Well, therefore, the novel dynamic lens architecture for industrial edge intelligence is proposed to adaptively learn sequence feature representation of different lens conditioned on each sample. In our method, easily predicted samples are calculated by upstream network with a part of the sequence, and subsequent networks are unused. Abandoning the computation implemented in upstream networks is inefficient, though upstream some networks conducted with short sequences. Therefore, to utilize the information, a feature reuse mechanism is proposed for better performance of IOL prediction. Experimental results indicate that despite the differences in performance and datasets, both dynamic models can speed up with minimal accuracy degradation or better performance. Here is another work about industrial edge intelligence. In most real industrial edge scenarios, there is a huge gap between the deep learning models, memory, and edge computing devices resources. So therefore, a binary trained aware network for industrial edge intelligence is proposed. It achieves a high compression rate while maintaining competitive performance with good hardware friendliness. Firstly, we propose a binary composite attention module for efficient feature extraction. Secondly, we propose a binary temporal convolution module to further improve the model's ability to capture temporal information. The width and activations are replaced with 1-bit data, which greatly reduce memory consumption. Experimental results indicate that the proposed model achieves significant memory compression and computational efficiency improvements while maintaining competitive prediction accuracy. Well, the second is cloud edge collaborative intelligence. Industrial cloud edge collaborative intelligence refers to the seamless integration and cooperation between cloud and edge computing resources to process, analyze, and act on industrial data efficiently and effectively. Cloud edge collaborative intelligence is vital for optimizing resource utilization, enabling scalable and flexible industrial operations, and ensuring real-time decision-making by leveraging the strengths of both cloud and edge computing. Cloud edge AI has to meet both accuracy and effectiveness simultaneously, supporting complex industrial AI models with limited computing power and the edge and the potential decline in the performance as working conditions change. In this work, firstly, cloud edge computing and AI-based framework for industrial prediction is presented to meet the real-time requirement. And secondly, a new model structure named a lightweight temporal convolutional network is proposed and applied in the framework. And then an incremental learning approach based on updating partial parameters of LTCN is to improve to accuracy of prediction models with newly collected data. Well, experiments indicates this framework improves the prediction accuracy and computing time. The second work in this part is label split multiple inputs convolutional neural network. Due to increasingly complexity and variability of industrial processes, data obtained from a single industrial edge is usually of low quality, including unbalanced, unlabeled, and unseen data. Therefore, we propose the cloud edge collaborative method for adaptive fault diagnosis with label sampling space enlarging, named LMCN. First, a multi-attribute label sampling space enlarging approach is proposed to extend the variety of diagnosable faults. Second, a multi-input, multi-output data augmentation method with label coupling weighted sampling is developed. Experiments indicate that the method can effectively dealing with unlabeled data. Well, the third is industrial data-driven intelligence. Industrial data-driven intelligence involves leveraging large volumes of industrial data to extract insights, identify patterns, and make informed decisions using advanced analysis and AI techniques. Which is crucial for optimizing operations, enhancing productivity, and driving innovation by providing actionable insights and predictive capabilities. The first one is called MAC10. It's proposed for industrial health indicator prediction, which can weigh contributions of different channels through the channel attention. To avoid the loss of temporal information caused by averaging along the time scale, learnable weight is used to obtain each channel feature along the time scale. Experiments show that the channel attention mechanisms are effective in improving the prediction accuracy. The second one is called long short-term memory deep factorization machine. Complex industrial data have diverse characteristics and nonlinear relationships and massive unlabeled samples. Therefore, data-driven self-supervised LSTM deep FM model is proposed. Specifically, we utilize unsupervised and self-supervised methods for feature generation. Multi-dimensional data, time series data, and masks and reconstructed with LSTM autoencoder to learn the theory correlation and inter-feature correlation of data, so as to improve the robustness and of the model to missing elements. In addition, we use aforementioned LSTM autoencoder as a pre-trained encoder. A deep FM model is constructed to mine the structural and non-structural correlations of the data and predict the final key indicators. Experiments show the effectiveness and the superior performance of the method. Well, the fourth is industrial digital twin intelligence. As we know, industrial digital twin intelligence involves creating virtual replicas of physical industrial assets and processes that utilize AI and real-time data to simulate, predict, and optimize performance. Digital twin intelligence is essential for simulating industrial scenarios, improving operational efficiency, and even involving parallel intelligence in industrial digital twin. Here is our work about digital twin intelligence. In flexible manufacturing, novel industrial parts occur from increasing demand for personalized customization in manufacturing. Grasp scenes become complicated and variable due to geometric and categorical differences of objects, bringing up challenges for fixed robotic grasping in pipelines. Therefore, a digital twin robotic system is proposed to generate a synthetic grasp detection dataset composed of industrial parts. A novel end-to-end deep learning model, adaptive spatial awareness grasp network with continuous learning strategy to prevent forgetting. Experiments show our model generalized industrial parts with various geometric contours and dynamically adjusts to scene changes in flexible pipelines. Well, the fifth is industrial metaverse. Industrial metaverse is a virtual collaborative industrial universe based on digital and virtual technologies. A conceptual model of industrial metaverse is proposed with three verses: cyber, physical, and social, with industrial AI brain in the middle. So the first characteristic is utilizing the test to 3D scene capabilities of AIGC. It is feasible to intelligently generate virtual modeling scenarios based on simulation requirements for various industrial simulation activities. Second is in spatial dimension, people collaborate across physical distances by breaking real-world spatial barriers. Besides, many diverse parallel universe worlds can be created for parallel intelligence. In temporal dimension, people collaborate in industrial metaverse regardless of time zone differences. Besides, it is feasible to manipulate time to revisit the past or simulate the future. The third, user can immerse themselves as digital avatars, seamlessly taking on different roles and actively participating in various production processes. This does not imply a lack of autonomy and intelligence in the industrial metaverse. Rather, it achieves safer and more stable production through human-in-the-loop systems. Well, the first, the intangible assets in industrial production include data, knowledge, models, and services. They are stored, protected, treated, and circulated in a decentralized economic system within the industrial metaverse in digital form. Dynamic collective intelligence is the fifth. Sociability makes the industrial metaverse not just a social network, but a societal structure that encompasses various effective ways to enhance productivity. This is applications. The first, collective intelligence-based collaborative design enables collective intelligent design, multidisciplinary real-time design, and intelligent design generation. The second application, producers' skills training utilized extended reality technology and wearable devices to provide immersive training for production processes through ergonomic assessments and operational guidance. The third application, customer immersive test experiments intelligently generate test scenarios based on customization and allows users to experience the comprehensive performance of the product in a single immersive session. Well, the fourth application, intellectual property transactions enables digital storage, protection, and trading of industrial assets. The fifth application, in normal state of product, a remote collection of usage data, periodic monitoring of product health status, and intelligent analysis for predictive maintenance are realized in industrial metaverse. In fourth state, industrial metaverse is capable of virtual collaborative troubleshooting, remote diagnosis of product status, provisioning of corresponding after-sales service. Where the last is towards industrial fundamental model. Since the last year, many AI fundamental models have emerged across various fields worldwide. These fundamental models with remarkable capabilities can accomplish tasks including but are not limited to the following. Well, how to construct an industrial fundamental model? The first solution is to apply existing large language models in industrial scenarios. For example, Microsoft control robots by ChatGPT-4, and Siemens generates PLC code by ChatGPT-4. And the second solution is to develop an industrial fundamental model independently. In our proposed architecture for industrial fundamental model, the base layer supports establishing industrial fundamental model neural network architecture. Then the model layer supports applications in smart manufacturing. So we developed a prototype for industrial fundamental model named FX, which now support AIGC for research and develop simulation system code and industrial digital twin scenario generation and robot control instruction generation and customer product process generation, time series data generation, and small prediction models generation. Here is one work about industrial AIGC. Due to data collection difficulty and privacy concerns. Available data for establishing industrial intelligence is far from sufficient. Therefore, a temporal augmented conditional adaptive model is proposed for the synthesis of industrial multi-sensor time series. In addition, a classifier-free conditional adaptive maximum mean discrepancy diffusion method is proposed for the controlled generation of MTS. Also, temporal decomposition reconstruction UNet is proposed to denoise and recover MTS data. Well, the experimental results verify the outstanding performance of the model and the great potential of diffusion models for generating industrial data. Industrial foundation models have to generate contents depending on various domain scenarios. Therefore, it is significant to study domain adaptation to address the problem of domain shift, which industrial foundation model may suffer from. The second work in this part is a meta-learning based domain generalized framework. This we propose a training framework for domain data generalization. And our method has excellent performance and achieved superior results on the set of generalization across various working conditions. So that's all. Thank you very much.
2 minutes over time, unless you have a burning question. Otherwise, we move on in order to keep everything on schedule. Thank you.
Thank you.
Our next speaker, Sally. Hello. Ms. Sally Redwan is the Chief Digital Officer at the United Nations Employment Program, UNEP. She has an extensive background in AI and emerging technologies, including spearheading Egypt's national AI strategy as advisor to the Egyptian Minister of ICT. Beyond her 17 years in the technology sector with global companies, Sally is an influential figure in the international AI policy, currently finalizing a PhD focused on ethical AI in metagenomics. So the topics today is the environment GPT, linking environmental science and policy. Yes, please.
Thank you very much. Good afternoon, everyone. I apologize for my slightly crooked voice. I've been suffering from a cold, but I hope you can all hear me. I'm not a manufacturing expert either, although I would love to work with UNIDO on sustainable manufacturing. But I'll talk a little bit about the environment. And before I start, I should actually let you know that we have a version of Environment GPT running downstairs. So if you want to run by our booth, it's right next to room D on the first floor. So you can get a hands-on experience, which we don't have time for now. Just a bit of background in case you're not familiar with UNEP. So UNEP is the UN Environment Program. We're based in Nairobi as one of 2 UN agencies based there. And our work really covers all 3 domains of the environment as you can see them here. So we work on climate change, we work on biodiversity, deforestation, nature preservation, and also on minimizing pollution and chemicals and so on. Across all of these, what we call the triple planetary crises, we work in digital transformation to address them, always keeping in mind that we want to deploy technologies to help achieve these sustainability goals, but also to make sure that technology itself is sustainable and environmentally friendly. similar to the digital transformation program, we also have a science policy program, which has these goals that you can see on the screen. I'm not going to read them out loud, but it's essentially trying to bridge the gap between science and policy and making sure that environmental policy is based on solid science and that it's accessible to everyone. So this is why we decided to build Environment GPT. It's basically to serve two purposes. One is to kind of simplify the science and make it more accessible to everyone. But then also the last point is to combat misinformation and disinformation, which, as you know, is quite prolific in the environmental world, unfortunately, especially with regards to climate change. So essentially, we wanted a ChatGPT that was just as approachable and easy to use, but that didn't hallucinate or minimally hallucinated and could give you authoritative science to work with. So, have you taken away control from me?
It's just try to help you, but not will not take over.
Not very successfully. So could you help me flip the slides, please?
Click with the mouse on the slide. Yeah.
Yeah.
Click.
Yeah, now you got it.
Ah. It was just focus that you've taken away from me. So we embarked on this experiment together with the AI for Good lab at Microsoft, and we took GPT-4 as a basis. In fact, we actually developed 3 versions of it based on GPT-3, 3.5, and 4, using the OpenAI API, but then also augmenting it with something called a technique called RAG, which the more technically inclined of you will know it. It stands for Retrieval Augmented Generation, which basically is a technique that helps you increase the accuracy of large language models by adding in insights and additional data from outside the sphere of your training data. And then the other thing that's different is that we trained it on a very well-curated, vetted corpus of data that UNEP scientists approved, instead of just going wild on the web and training it on everything available, and then ending up with lots of hallucination. So this was essentially the process. We started, like I said, by choosing this corpus of data. So we're talking about IPCC reports, regular UNEP reports like the emissions and adaptation gap reports, but also scientific papers published in the public domain that were approved by our scientists. And then we started with GPT-3, 3.5, 4, and used this RAG technique to increase accuracy. Of course, GPT-4, once it came out, massively outperformed anything that came before it. So we stuck with the GPT-4 version. And then to validate, we put together a list of 30 questions. I should say that the current version only covers climate change and air quality as topics. So we haven't gone yet into biodiversity and pollution and all the other things. And we developed 30 validation questions to ask it and for our scientific community. So this includes the International Science Council and all the scientists that work with UNEP to validate the answers to these questions. Now, the idea behind Environment GPT is that while it tries to give you the best answer it can, it does 2 things. First of all, it also gives you the reference from where it got the answer. So you'll see chapter and verse, essentially. This came from the 2024 IPCC report page, so and so. But if it finds 2 contradicting opinions, which is often the case in environmental science, it will also give you both, so you can trace them back to the source. So we validated on these 30 questions with our community of scientists to make sure that the answers were acceptable, and we kept iterating and adding more training data to increase the accuracy. And then, like I said, we started with a very small corpus of data. We kept increasing it. We're now up to, I think, over 100 sources, if I'm not mistaken. And this is what it looks like. So it's a fairly uninspiring UI, I'm afraid, but we try to keep it simple and to the point, right? So at the top here, you can see what it's about and kind of the background. The cards in the middle, where it says air quality, are essentially ideas that you can use, so sample questions in case you don't want to formulate your own question. But then, of course, you can just type a random question and hopefully it'll give you the right answer. On the right and in the version you'll see downstairs, you can also give us feedback because this is still a closed beta, so we're just opening it selectively to groups of trusted audiences, and we're in no rush to go into production because one thing you shouldn't do with AI is rush it. So we're going to run this closed beta for a while, and on the right here you can give us as extensive feedback as you'd like. In terms of the next steps, like I said, collecting feedback is important, so we started showing it at COP28 last year. We're showing it now. We're planning also to show it at the HLPF in New York and at the Summit of the Future, just to extend a little bit the sphere of inputs and feedback that we're getting. And then, of course, we want to also create a wider corpus, not just of text, but of other means of information like images and graphs and so on. And then we plan to take it into production. And while we do that, of course, we need to practice what we preach. So the goal is very much to minimize its environmental impact. We're already doing that by using a minimal set of training data, but we also need to make sure that we select the data center where it's hosted and make sure that the end-to-end impact is minimal. And of course, we want to broaden the topics. So beyond climate change and air quality, we want to also go into biodiversity, chemicals, pollution, and so on. And then also create interlinkages with other types of data sources. So one thing that we always say is we need to link the environmental agenda to the development agenda and understand causes and effects and potential impacts of climate change, for example, on the economy, because this is the message that member states in the Global South really respond to. So we hope to do that in the next few months as well. We have a few potential use case derivatives in mind as well, based on Environment GPT, including a natural language query interface for our flagship data platform, which is called the World Environment Situation Room. I won't have time to show it, unfortunately, but maybe on another occasion. And this is basically if you're a non-technical user, but you want to see, let's say, a custom visualization or dashboard on the spot of show me the impact of climate change on biodiversity loss in Brazil over the last 10 years. You should be able to express that query in natural language, have the system translate it into a set of technical queries, create that visualization, and surface it for you in near real time. So these are the kinds of use cases that we're looking at. Another one we're looking at with the European Commission is something called the net impact analysis of AI, which is basically mining all the data that we get on the potential costs and benefits of deploying AI in specific use cases to calculate whether this would be a net positive or negative impact of certain AI deployments, and using that as criteria for applications to funding bodies and donors. So these are just a few of the use cases that we have in mind, and there are more springing up all the time. Once you have something that people can play around with, they start to come up with all these great ideas. So we're open to other ideas and collaboration if you want. And this is me. I hope I didn't go over by too long, but thank you very much.
The floor is open. We have sufficient time for this. Yes, please.
In the interest of gender type equity, I will ask you a question because we should have 2 hours, the two of us together. I think as a former information management professional, so a trained information management professional, I feel vindicated that even with the latest technology, the garbage in, garbage out still applies. So we have this experience with trying to feed the LLMs with the non-vetoed data, and the result was between frightening and hilarious. And so I know that that's a big challenge, having high quality information, accurate, authoritative information for the GPTs is really crucial. But my question for you, was that the worst part, or does it get worse after?
The worst part in
No, what was the most difficult? What was the biggest challenge that you got in training these LLM, training the LLM?
That's a really good question. I think deciding on the sources that we used, because I mean, a big part of the problem with AI is humans, right? And the fact that we tend to translate many of our problems in the physical world to the AI world, and one of them, of course, is hallucinations. But I think getting all the scientists to agree on the authoritative sources for different topics was particularly challenging, and also deciding what's an acceptable answer. The validation we did with the 30 questions, we got quite varying responses and evaluations of the different answers. So getting them to converge on a set of, yes, this is good enough, was not very easy.
Yes.
So
yeah, the distance between a plausible answer and an acceptable answer, right?
Exactly.
Because any GPT will give a plausible answer.
Exactly.
Thank you.
I have.
There's a question behind than you.
Yeah, thank you for the presentation. I was going to ask, why did you use GPT models? Is it because of the partnership between you and Microsoft, and also the alternative one? Why don't you train your own LLM?
Couple of reasons. When we started, GPT-3 had just been released, and it was the best thing available.
Mm-hmm.
And we were working with Microsoft. You're absolutely right. So it was a combination of factors. Training our own LLM from scratch seemed like a waste of energy, to be honest. So it was an environmental decision to say, unless we can really justify creating something from scratch and training it from scratch and using up that much energy and water and all the things that go into training an LLM, which I had a slide in my presentation yesterday, if you've seen it, that says training one large language model basically produces the same amount of carbon footprint as 125 return trips from New York and between New York and Beijing. So that's quite a lot of environmental damage that we would have had to justify. And we felt that starting with something that was already there was good enough. If we had ended up with really unacceptable accuracy, then that would have been enough reason to say, okay, let's try our own. But so far we haven't.
Here's a trivia for this, I think. When you use retrieval augmented generation, you reprocess again and again, same documents, when you have the same similar questions. So that means you retokenize the document to the GPT model, which increases cost. I think in the long term, you should be considering the own LLM option. And also there are some fine-tuning tools, like small language models can be fine-tuned among these task-specific scenarios. Like, did you consider that? Or?
Yes, and we actually did a bit of fine-tuning. I just didn't go into massive detail. But yes, small language models are certainly an option for us when we go into production. And you're right, RAG is not cheap in terms of the overhead that it generates, but it was still, for the prototyping phase, it was still better than creating a large language model.
You focused on minimum viable product then.
Yeah. Exactly. when we transition into production, it might prove more feasible to create something from scratch. We'll see.
I really like the idea. Thank you.
Yes, please.
Well, just a short question. So it's a brilliant ideas to have ChatGPT to actually, incorporating the environmental sustainability and whatnot. So my question is, does it have the deterministic kind of outputs, for example, in determining air quality index, for example? So, there's a lot of parameters within the air quality index, the carbon monoxide, the nitrogen and whatnot. And does it have that capabilities to determine what is the levels of the air quality index in particular AQI domain?
That's a great question. The short answer is no. It still is non-deterministic. It's still only a large language model. So we did not move away from the probabilistic nature. However, we did minimize, I would say, the amount of hallucination that is likely to occur just because it is trained on this well-curated body. However, it can still string together nonsense from a well-curated body. That is completely understandable. The other point that you mentioned is one of the things that we're hoping to accomplish in the future, which is to actually kind of achieve a consensus view on certain questions. At the moment, all it does is it will give you the different views if it finds different perspectives to a specific answer. But making it able to actually extract data out of text and treat it as data and use it for analysis, including to achieve consensus levels and ceilings, for example, for different air pollutants, is a next step that we're hoping to accomplish at some point. If you can help us, please let us know.
Would love to. All right. Thank you.
Do we have any question from online audience?
We're scared to look.
At the same time, if you have other questions, please raise your hand.
Seems no question from
Yeah,
online.
yes, please.
Yeah. What
Question
sort of
here.
data forms does the UNEP collect in terms of the environmental data? And how are you able to vectorize this data for the LLM?
Oof. So for the LLM, it was just text. So we just used scientific reports and so PDFs essentially, nothing fancy. However, in terms of the data we collect and federate, that's a whole different session on what we call the global environmental data strategy, which is another thing that we're doing. And there we're trying to harmonize standards for the exchange of environmental data, also kind of unification on acceptable levels of certain things, including air pollutants. But the thing about environmental data is, of course, and you probably know this, which is why you asked the question, it's very, very diverse. And so it's quite difficult to harmonize and to extract meaningful insights from. So the global environmental data strategy is hoping to reduce that uncertainty a little bit and to allow us to combine different types of data. Now, if we combine that with the ability of a large language model to extract data points out of different types of data, that will, of course, be the holy grail, but we're not there yet, unfortunately.
Thank you.
Great. If no other questions, we will move on. Thank you, Sally. You saved the time and we're back on track. Thank you.
Probably the first time in my life I've done that. So proud.
Now let me introduce our next speaker. Next speaker is Mr. Kim Barris. Behind me, right? Yes. Kim serving as the statistician at United Nations Framework Convention on Climate Change Mitigation Division since 2014. He plays a pivotal role in shaping the division's data strategy and integrating advanced data services. With a rich background in data science and a PhD from Barcelona Tech, Barris has the notable advanced AI initiatives within the UNFCCC employing deep learning and natural language processing to foster AI diplomacy and decision-making processes. So his topic today is AI diplomacy, leveraging large language models to support climate negotiations. The floor is yours.
Yeah. Okay, thank you. Thanks a lot. It's exciting and scary to be here, I think. Yeah, we are climate change, UN climate change, but we don't climate change. They do climate change. That's why we find a catchy name that is AI diplomacy. That sounds very, very fancy. Yeah, basically, this is my schedule. And we can say that this thing starts years ago. And the first learning thing is that don't try to build an empire alone, because it's not going to work. You are going to finish the day and going to meetings and regular work, and nothing is going to happen. Nothing is going to move. That was something that I learned. And based on that, I started to try to build a team specifically for that. Yeah. What is our mandate? Our mandate basically is to try to generate good information for negotiations. It means data as classic data, numbers in tables. That is not in our hands. What we have is a lot of text. For example, the NDC submissions, the BURs. Well, we are the kings of the acronyms. But one day I got a question that is like, can you manage 10,000 pages per year and extract absolutely every single statement made by a party? I said, I don't know. We can try. But you can imagine that it's super expensive to do manually. And on top, I think I have never done that manually. I think it can be quite boring. Well, the solution is, let's go to try something. Let's go to try to start extract information, and let's go to try to get to be 100% precise. That means basically, as a first goal, eliminating false negative. It means if something has been said that is important, needs to be in the report. On top, we need to think that we need to put humans in the process. You know, this is climate change. It's not another topic, the sensible topic of United Nations, but imagine that we let the machine write whatever and we end in a world war easily. Yeah, we are in climate change, we are more Pacifics, but still we can generate a lot of problems. Basically, the sources. We have three types of sources. We have the political data, that this is these documents that, and some people think that these documents are created in a way that nobody can read automatically with the objective of make our life more complicated. But no, it is not. If I ask you to explain your summer holidays and I give you some things to click, you are going to say, I cannot explain my summer holidays here. And imagine explaining the objective of a nation for 10 years. Yeah, it's like, yeah, click here. I have this form with 20,000 fields, and I start to click. It means they need to have the freedom to write and to do in their own way. We will be super happy that they were more structured, but the reality is that they have different capacities, different teams, different locations, different culture, and this needs to be reflected in the documents. That is the first part. The second part is diplomacy data. That is this when we are in the meetings, what they told when they make statements, the president is doing the high-level statement or a press conference. All these things are data for us now. They were not before. 5 years ago, it's like, well, yeah, let's say no more. And finally, we have climate data. Not a lot, but we have GHG databases, and this is our data. As you can see, I think 99% of the data is text and non-structured text. Integrating this data, it's extremely complex. And this will be a fantastic solution. The solution will be the integration of all this data in order to try to find holistic solutions. That will be perfect. But we are really far away from there. Where we are is here. We are able now with LLM to solve a new branch of problems. Yeah, but still we are creating one tool to solve one problem. If you have good developers, as I have, then you can have models, and with the same model, you can use for several tools. But yeah, the idea of creating a space solution, multidimensional for the multilateral negotiations is super fancy, Nobel Prize for representatives that like that. And this is, I think it's interesting to explain the path, because some people is starting in this wall, and it's good that they don't do the mistakes that I did. I produce entity recognition systems and text classification and scrappers and all types of these things in the 80s, and in 2018, not in the 80s, I was a kid, in 2018. And I just try to remember yesterday what I was doing in 2018, you know, and yeah, it was that. And then the first big point is when I achieved to contract the first pure data scientist. At that point, I contracted data science. This data science course is going to do other things. There's the TOR is one thing, and what happened in the reality is I need help with 20 different things. But at least 50% of his time was dedicated to this. We start to develop products, still slow. Then we open an internship, some internships. And from these internships, some people, well, a lot of people were in these internships. I think we had 8 interns before we contract one. And now we have 2 former interns that now are consultants, age 23. I can be, yeah, I can be his father. And with 4 people, me not doing anymore anything on that, one 50% and the other 2 100%, we started to see the results. We started to produce good, well, acceptable proof of concepts that I could show to my bosses. And from there is when I got the approval and the support, total support of my bosses to get some money, because of course I had nothing at the beginning. And that is the game changer. From there, we start to develop, and now, yeah, we develop a complete tool with a front end. You know, front end is something that I'm not good at. I produce a lot of data, but then when it's time of the front end, it's like, this is not my part. But it's super important. You know, you can have the best tool of the world. If you don't have a good front end, users are not going to use it. And internal users are extremely complicated. Okay, once at that, let's continue. This is our ecosystem of tools that we have right now. There is one big tool that is this intervention analysis tool. This tool is a tool that we use to analyze a speech made by a president or to analyze documents. It's the same tool. The models change, but it's more or less the same tool. I will explain a little bit how this thing works. You can see that we produce Excels and Words. It's like very, very basic. And then we have a couple that they have a web page. Yeah. But I have to say, the specialized chatbots, we stopped working with them because our users were not using it. Then they were not, no, I don't know. I had a lot of expectations in the chatbots, but no. But the other ones are working well. Some of them have 2 or 3 chatbots connected. And I will explain a little bit what is the technology behind, and because I think that is the butter on the bread. Then we have a decision proofreader, and there is 2 tools in one, and something that helps us to draft. After having this tool, I have draft decisions. That is like, I'm a mathematician. I'm never going to draft a decision. Now I can draft decisions for the documents. And this is the one that we are just finishing with the front end mandate tracking system. It's a tool that is able to identify mandate in our decisions, extract the mandate, understand the date. It's not important if the date is not a date. It's something like next scope, next session, because we know in which document is written, we know that type of meetings and the periodicity of these meetings. And then there are rules. Of course, we don't do everything with LLM. We still use some regular expressions. They are still useful. But with that, understanding what is the output, we can prepare the workload very fast for next year. This has not been proved because it's just finishing. We have proved with some documents, but it seems that it can work super well. Okay, if we go to the intervention analysis tool, basically our problem was that summarization, imagine that this is the meeting room. The first speaker show a picture of that, and everybody speaks about one topic, one after each other. And then we change the topic to another thing, to another topic. And this lasts 2 hours. And then you have like 20 pages of something and ask the machine to summarize that. The summarization is, you can imagine, there's nothing to do with something that the UN can use in any way. What is the solution for that? We analyze, in this case, because our intervention by intervention. When the interventions are too long, we go paragraph by paragraph. And we ask the same question to each paragraph. Okay, extract the bullet points, or it can be bullet points, can be anything. And at the end, we store in our databases bullet points or statements, or the definition of the statement, the real statement. Means we ask the machine to give us also from where this is coming. We also add, if it's a speech, the time in the transcript. We add topics, subtopics, speakers. Well, we don't add the speaker. We translate the speaker into the party or country or group. And with that, we generate a database. And this works because you have statement by statement, basically. Do you want to know about one specific topic, gender? Then you filter by gender. And then you ask for the summarization. You want to know the position of one specific country or group? You do the same. It means it's in the second iteration when you get the summarization. Or normally what happens is they simply filter in Excel and they work with that to create their own summary. Yeah, it's not, they don't need to have a summarization. Only when they are really, really last minute, they ask, can you prepare the summarization for us? But and then basically for the chatbots, what we were using racks, yeah? And we are chunking everything and adding metadata to every single chunk. It means every 800 words, we added all the metadata, who is the speaker, who is which day, which meeting, everything, to try to make the chatbot have some intelligence. We work a lot on the prompting also for the first case. The prompts are, sometimes we ask a question to a paragraph like this, and the prompt is like this. Yeah, because we create a base prompt, we spend a lot. I thinking now it's like what, maybe we spent 2 months to create one excellent prompt. Looping questions, positions, this is more things, similar things. When we are using looping questions, imagine indices, the document. We go and ask the same question to each paragraph. Computationally, is an atrocity, I know, but we cannot lose any answer. That's the question. That is the idea. And we ask the same question, and it's asked in a way that the model has first needs to answer yes, this topic is inside, and then we ask, okay, explain exactly, because we want to avoid hallucinations. Okay, that is the main objective. With that, what we get is a kind of, imagine an Excel where you have all parties and countries and all questions that you want to ask. In NDCs, it's like 800 questions or 1,000 approximately, and you get the answer for each case. But if you take that and you make a funnel, it means you take one of these columns with all the answers to one topic. You can ask the machine to create positions and say, okay, tell me what is the most typical. Now we stop being perfect. What is the most is very ranking thing. What is the most typical, I don't know, policy that is working in all countries on this topic? Yeah. And then the second, the third, and the fourth. With that, you can write a kind of what we name synthesis report. Yeah. This is same products mixed up in different ways. Then the other product that this is the proofreader and the writer. We train the model with our own paragraph. Okay, we collect documents from the past. Somebody had that documents. And we had the first version and the final version. And we create something that it was, okay, let's see what is the difference between one and the other. But then, yeah, it was nice, but okay, how to make this thing working? It's still the last step. We have to test it. And basically what we have right now is you have a document, you click a button, the AI is working, and you get back the same document. In the same document, in track changes, you can decide. Okay, you like this word, you like the other word. This is more UN style. This is a little bit more freedom in the wording, because this thing of creating a new complete document or a new document with the changes that has been done under, it's complicated for the user. And this was not our idea. It's the idea of the owner of the product. And finally, well, because we were so engaged with destroying Microsoft Word from the inside, we create a system that can change the format completely. And this is not AI. Simply you define a format and boom, you get the UN format.
Time saving.
Yeah, it's a time saving thing. Everything is about time saving here, you know. And yeah, I said the mandate tracking system. I explained a little bit. He said basically the mandate tracking system identify what, who, why, whom, who is going to work on that, so on, so on, and put in a system that it's super easy to modify, because, you know, I say, okay, I assign this to that person because there are these keywords here. It's like, no, it's not mine. Okay, let's change it. It's so easy like that. But we reduce time. All products have a final result to save time. This is the mandate tracking system. The visual, you can see that what you get in mandate is not exactly the mandate. It's a summarization of the mandate. Then you get who is the speaker. It's a version. You will see strange things here in the middle. Don't pay a lot of attention. The deadline. And then when you click in one of the mandates, in the other side, you can see the real mandate. You can read the original mandate and see, oh, this is not mine, you know. And then in the bottom, you can see how we assign milestones, but this is rules, nothing else. You know, if this is a workshop, okay, we need to pass all these steps. We need to call conference affairs. We need to do this. We need to do that, and send automatic emails in order to have track and not be surprised because you have something to do next week. Yeah. Well, basically, this will be a standard thing. We are agnostic on technologies. Okay, in LLM, I put a little bit of everything. I could take more time and choose more models, but we are using basically Python to program. Everything is in GitHub, and then we simply standard way to work. Basically, if this is a speech, we can have 20 rooms, speaking at the same time with press conference, and so on. Of course, we don't record anything that cannot be recorded. Yeah. And we have virtual machines that they record and then we transcribe. Yeah. There is This part at this moment, part of this is we are still using a commercial product because we are working on this with Microsoft on this part. Okay, but the idea is exactly the same. We have a speech recognition, speak identification. The difference is one identify that this voice is new, and the other identify that that voice is from that person. But we don't use names. We use names internally because otherwise we started not using any name. You can use something like male 1 USA, male 2 USA, female 1 USA. The gender is good because when you normally you can catch if it's a man or a woman, if it's video, of course. But at the beginning we were writing USA, but then we have 20 voices that name it USA, and it was the machine was crazy. It was like, no, I'm not gonna bet anything because it's not working. That's why we moved to have unique identifier names. That can be the name of the person. If it's a known person, it's a president, it's obvious. But also can be simply that, because sometimes you have round tables with 200 people online, and you don't know who they are. And simply say, okay, this is from this NGO, main 1. It works well. And then the translation is the NGO. It's not important who is speaking. What is important is who is representing. In the second part, what we do is we put our LLMs to extract all this, the result of the question and all the metadata, and we store. And from there, we start to create products. You know, the first database is the first way, is the important point for us. Having a database that store every questions that we ask. During a normal conference or normal any session that we have, workshop, whatever, we can ask 10,000 questions in 3-4 days to the machine. Yeah. Because we split by paragraph, and you ask every paragraph question. What has been said? Explain me. And well, after that is when we go into the product. The second database is the specific problem that generate specific solutions. It can be, you can have 1 there, 2 LLMs, 3 LLMs. It depends how complicated is the system. In our case, it's maximum that we have used is 3. We use a lot 3.5. Now we probably will move to 4 or 4 is too expensive. And 3, 4, and too creative sometimes. He love to speak. It's like stop. Then and with that, working that way, I'm sure that there are better ways. And I'm happy to hear and save money. We control the hallucination 100%. We demonstrate, we show that irreliable, because normally when there is a president speaking, we have 3 note takers. And we compare for a lot of time that, and the note taker said, I'm not going to do this work anymore. We cannot be better than the machine. Yeah. Next steps. Continue growing the ecosystem of proof of concepts. Yeah, new ideas are always coming from colleagues, from a lot of people. Improving the automatization, because without automatization, there is no scalability. Every time that we put a man in the middle, it's fantastic because it's perfect, but we are slow. And then creating front ends. It's also important, thinking on front ends. If you don't have a good front end, you don't have a product. That is now what I'm thinking. Yeah, moving our proof of concepts to enterprise probably during this intersessional that we are starting in 2 days session, then COP in the middle, we will try to create more holistic things. That is the complex exercise. Yeah. With that, I'm done.
Floor is open. Any questions? Yes, please.
Hi, thank you for your presentation. I had one question regarding the system prompt. What have you most built an excellent prompt?
The prompt for itself is an exercise of creativity. You know, we have a base prompt that we keep, one part that is always fixed. And then after the base prompt, we add the real question. Maybe after that, we add another piece of base prompt. Yeah. It means to send the question, we are really also programming something that makes that the prompt is good. Because yeah, it's a machine. You want to ask one question per second, something like that. The way is that. And we have several base prompts. They have to be really, we spend a lot of time testing those prompts with documents manually and asking the question, and okay, it's not working, let's change this. Somebody put a trick in internet, you ask them to be super whatever, it was much better. We tried, it's not working. And also, we like, right, that the repeatability is there. You know, this is very scientific, but at least as a concept that it never changed, the concept that is given to you. Yeah, because yeah, but the base prompt is also a program. It's not something that we write and we let go. No, it's built before the question.
Yeah. Thank you.
Okay with you. If there's no further questions, thank you, Kim.
Oh, we have one from the.
Okay.
So I'm just curious, what is the evaluation framework for chatbots? So how, I guess, like, how do you evaluate the success metric of your chatbots?
One metric, there are two metrics. One is the quality of the answers. The other is if people use it.
Yes, even the user is not happy.
And they were not using it. I was using it, but nobody else. And it's like, okay, please stop spending money on this. You know, sometimes the tool is not good. Sometimes we don't communicate correctly things. And the other problem is that sometimes the organization needs to be more mature in these techniques or feel comfortable using these tools. It's a mix of things. Then it's a long way. You know, you buy a tool and it takes maybe 2-3 years to institutionalize the tool. Except if you have COVID, of course, then everybody moved to Teams in one day.
Yeah, there's a question here, then you.
Thanks, Joaquin, for your presentation. You mentioned several times in your presentation that your LLMs are hallucination-free, and that's also 100%. That's a strong claim. So I was just wondering, because what have you done, or if you can give some insights?
Okay, we can say that it's almost, yeah. This is not a scientific presentation. No, you know, if you reduce the context, you chunk a lot. You don't let the bot to hallucinate. Losing of attention is what made them hallucinate. As example, if you have a NDC document, yeah, this is where we explain what we do in mitigation, what we do in adaptation, what we do in technology transfer. But gender or diversity is everywhere. Okay, if I ask the machine directly about gender or diversity, what I will get is a partial answer or maybe hallucinations. Yeah, but if I ask paragraph by paragraph, there is something related to gender, and if there is something there, tell me. I take that piece, I save that piece, and I do the same for the whole document. At the end, I have, because it's very difficult that one GPT-4 in something like this start to hallucinate. And on top, we have it's an easy wall. The wall of the official documents is much easier than any other wall. You put a poem, it's going to hallucinate maybe, yeah, with one poem. This is not free, but it's, yeah, good, very good.
Yeah, we are 4 minutes over, unless you have a very simple question. Otherwise,
I can later.
Yeah, well, I have to catch a plane.
I can text you via LinkedIn.
Yeah, sure.
Okay, thank you, thank you.
If
Thank
it's
you,
okay.
Kim.
Yeah.
So let me introduce our next speaker, Ms. Paula Nishio de Sousa. And Anna is back again to talk about another topic. And Anna is the chief of the Division of Digital Transformation and AI Strategy, Directorate of Technical Cooperation and Sustainable Industrial Development at UNIDO, United Nations, right? You know UNIDO. So the topic is UNIDO Digital Transformation and AI Strategy. And the floor is yours.
Thank you very much. And thank you for everybody who are still powering through a Friday afternoon to listen to us. So my presentation is split into several sections. First, I'm just going to talk a little bit about UNIDO because she said now everybody knows about UNIDO. That's not really true. We are in Vienna. We're not so big, so no shame in my game. I'm going to present UNIDO to you a little bit and a little bit of our work. Then I'm going to do a number of different projects that we're doing because we have a lot of diversity in the concept of industry for UNIDO is not, you know, those factories with smoke coming out. It's the productive sector. That's the meaning of industry. So it's much broader than it looks. And last, I have one very interesting project for you on rural development, use of visual language models in rural development. It gets very nerdy. So if the time is not helping me, I'm going to skip through that part. But I hope I can also cover because it's very interesting. So what does UNIDO do? So what is our mandate? Our mandate is inclusive and sustainable industrial development. And our focus is always the global south or the global, or as we like to say, the global majority, the G77, developing countries, economies in transition. So of course, we are the UN and our mandate is to be inclusive, leave no one behind, and make sure all countries can profit from industrialization. Because one thing that is very important, you can get any developed country, they all have high industrialization. There are no exceptions. There are no exceptions. So we believe in industrialization as a very strong pathways to decent employment and prosperity. But of course, we need to talk about sustainability as well. So our work is also very much towards decoupling prosperity, economic prosperity, from negative environmental impacts. So we have a very important people working in energy transition, people working in circular economy, so that people can still have prosperity without a big impact. So for us, it's all about smart manufacturing, smart circular economy, smart agri-food, smart energy. So what is our vision on digital transformation and AI strategies? The team in this composition that exists for, I don't know, 2 years, more or less. So we are still building portfolio, we're still growing, we're still making ourselves known. Most people who know UNIDO do not expect to see a digital transformation AI team coming. So, but what is our vision? Is, well, of course, SDG 9 is our bread and butter, you know, industry, innovation, infrastructure. That's where we are better represented. But of course, through SDG 9, we touch all the others, all the other SDGs. And of course, SDG 17 is very important for us. We're very focused on partnerships. So we want our mission is to enable everyone to address the challenges and reap the opportunities and benefits of the fourth industrial revolution. We're also starting to talk about fifth industrial revolution, but it's not very mainstream yet, but it will come, So we talk about smart production for advanced climate action, innovation, digital transformation for economic development. We are very strong in SMEs, for example, work a lot with women, youth, vulnerable groups, and the improvement of livelihoods using AI-based technologies. So our vision and approach, we advocate a people-centric approach to digital transformation, where innovation and advanced technology serve human welfare and environmental sustainability, and not the other way around. That's very important. So people are the center. Technology is important. My team is mostly, we're a bit nerdy, but we don't lose track that it's about the people, it should benefit the people, it's by the people to the people. So our approach to drive technological and economic transformation, because we believe that technological transformation brings economic transformation. So we work with trade facilitation. We are very strong in digital trades and e-commerce, industrial modernization, investment in technology and innovation. We work a lot with SMEs, but of course, very hard to work with them one by one. So we work with clusters. We tend to cluster SMEs in certain value chains. And through the angle of industrial production, we work with technology parks, innovation parks, quality infrastructure, so that SMEs are more competitive and can reach markets, external markets. One thing that we do a lot is for a development country to be able to export to the EU or export to Japan or export to developed countries. So there is a lot of compliance to regulation, so that through digital transformation. So let's talk about UNIDO artificial intelligence a little bit. And so what are we trying to do? I think UNEP already talked about making the bridging the gap, the digital gap. So also UNIDO loves to be the bridge. And in our case, we're trying to bring economics in transition into the fourth industrial revolution. And how do we do that? What kind of things that we do? We work on knowledge and skills. Capacity building is a very important for us. Global forum and partnerships. So UNIDO cannot do it alone. Government cannot do it alone. Private sector thought they could do it alone. They cannot do it alone. So we bring everybody together, and together we are more likely to succeed, bringing everybody's perspective, bringing everybody's strengths. Technical cooperation is our bread and butter. We have a lot of projects in developing economies. We also are very active in research and policy advice. So many others. Ours is more action oriented. Because it's also because there is a lot of feedback from the work that we do in the fields and the insights that we bring in our normative and knowledge products and normative work. So the idea is to bridge the gap, overcome challenge, and reap the benefits of digital transformation. So now I'm going to go through some examples, practical examples. They are not fiction, not theory. They actually happen. So just one example of normative on how do you empower SMEs through fourth industrial revolution technologies. SMEs are more than half of the GDP globally. They are most of the tax base, and they generate the majority of employments. And if you're talking about an economy in transition, you cannot not talk about SMEs. So we're very strong in SMEs, and SMEs are interesting because when you talk about this big revolution and you see these open AIs and those Microsoft and Siemens and it lacks awareness that is for them as well. So there's a lot of work, even in the most basic ones. We're going to be delivering webinars in Latin America, webinars to Lusophone countries, webinars, very simple. Just say, did you know that you can do this? You know, this level, because it triggers our conversation, it triggers our demands, and it triggers more development, more action towards implementation. So we are actually very active in the automotive industry, because when you think of automotive industry, you think of the big companies, but there's an entire ecosystem of parts and around, of services and parts around, and this is very SME centric. So we've been working in Belarus, Colombia, Mexico, India as well. I think we forgot to put that one. And when we do training and counseling, we do digital platforms, we do the links, we bridge them, we make sure that the work is of enough quality, that there is a quality infrastructure, application of standards, and digital supply chain network. So also to serve the automotive industry. So that's very, very a bit different, not something that people will think, but also something that we are very strong at. So another example, and that's more on the normative side, we worked on strengthening the implementation design of artificial intelligence of Jordan. Jordan had a policy and couldn't get on how to make that policy translate into strategy. And how to, because policy is great, but sometimes you need to, but the best part of a policy is implementing it, right? So UNIDO came and with just preparatory assistance, that was 3,000 euros, we could create a roadmap for them. We could create an actionable strategy. You could get any consultancy firm and they will get a strategy for you. But it's very hard to get an actionable strategy sometimes. So they had failed a few times already, and then they call us. And we did it. So of course we created a whole roadmap of projects, lots of opportunities. We're all now looking for people to fund those opportunities, and that's how the work continues. That's how the work continues. But for this little nugget of preparatory assistance alone, they went many positions in the rank of AI governance, for example. So they have a plan. So implementing the plan is hard, needs financing. We need to bring now the partners together, but that's normally how it starts. So that's why I have strategies in the title, because that's where it normally starts on the strategy. So using Internet of Things for energy, like working with piloting IoT technologies in Kenya for geothermal energy production. Let's take the picture and continue.
Thank you.
And so Industry 4.0 in clean technologies, global clean tech innovation platform in Pakistan, in South Africa, using for resource efficiency, for productivity. So we have lots of examples. This is a platform, so we have lots of examples from all over the world, from Turkey. So blockchain and smart lenses, or some examples in Ghana. We are using IoT and AR to give remote technical assistance to test laboratories. So we also have very interesting concepts in AR, VR for capacity building, skills development, and blockchain for traceability is a big one. We have a few examples. We also have a blockchain center in Tanzania. This one is readiness of value chain for blockchain for traceability. It's also a big technology that we hope to be working when the European Union will implement new regulations, digital product passports. So there will be a need to traceability and the circularity of the value chains. So they started with the easy one, industrial batteries, because they are like big, a handful of big companies, so very easy. And they want to go into textiles. So that's gonna be a nightmare. So we need something more powerful to work with that. And that could be blockchain. I don't like to say, I'm not technology first. I don't want to, and I've been through the years of blockchain hype, which were very annoying because I was helping evaluate the projects. And the thing that I used to say the most times is, don't throw a blockchain when a database can do. Don't throw an ace when that you can do. So it has a context that needs, and the problem needs to match the unique capabilities of the technology. That's something that we also believe very strongly, even though it's high pitch, even though it attracts more funding, but blockchain is computationally expensive. So we also need to keep that in mind, that the technologies, those advanced technologies can be computationally expensive. If they are computationally expensive, they are energy expensive. If they are energy expensive, there is a carbon footprint. LLMs are also super. So please don't use an LLM when a search would do. The energy consumption is 6 times. So another example in Venezuela, agro industry upgrading modernization program, simple resource efficiency to increase the yields of crops, of staple crops like corn, corn. I forgot. It's supposed to be 5. I only remember corn, but there is something else there. To ensure food security, strengthen the agro industry value chains, stimulate employment, and revitalize industrial sectors in Venezuela. And now the deep dive. And the case that I want to show is in Namibia. And it's if you just see the one pager of this project, you will not think that it's a digital project at all, because the context is bush encroachment. And they have Namibia is a very dry country among the sub-Saharan Africa, is one of the driest, and they have a problem of bush encroachment, acacia sickle, that takes away agricultural land. So it's a plague, it's an invasive species of, before the intervention, of negative economic impact, of negative economic value. So that's the problem. They have all these bushes, nobody planted them, they were just there taking up space. They were burning it. So there was also an environmental impact to it. So that's the problem. So let's get to the solution. So we picked a region in Namibia. It's not the only region that has this problem, so that we could do a pilot. And the pilot was to, okay, let's see how can we, what's the economic value of this flake? Is there an economic value to this flake? And is there a market? And how can we harvest this sustainably? Because of course, if you didn't plant, you don't know where it is. You don't know how much there is. So it's very difficult to make a pitch. It's very difficult to make a feasibility study. So that's where the digital came in. What we did is develop a machine learning model that would identify the species, acacia specifically, there is another bush, and map so that we would know where they are, where it's useful, how much could we harvest, and so if there is enough to, for example, the idea, the main idea was to create a plant, because the evaluation showed that the biomass had economic value. You can make coal, you can make pellets, you can make cattle feed with this. With this. So we just need to see if we had enough biomass to make a value chain productive, to make it productive. So the data input is field data from satellites and from drones. So we had to train the model, labeling, and start creating a model prediction for acacia, so that they could start identify what is acacia, what is something else, what is a cow, what is a cow. So let's start with the data input. So very high resolution image from digital globe. So that it was good enough to identify a single mature tree. So it was literally so that we could literally count the trees. And then the field data, because the satellite is very high. So we had to have some help from a bit closer down, and then we worked with drones. So we trained the drone. So the drones were there taking imagery as the training input for the machine learning model, and it was applied to the entire image to get the prediction on what's acacia, what's not. So, for example, this is the drone data, so it's much closer, and we can and with that level we can confirm the acacia species. Because it gets a bit closer. And then the predictor variables to classify the satellite image using machine learning model, and then we can label, which can be used to train the same satellite image in a different area. We're working with a very specific area for training for the pilot. And then we start the labeling, right? So the one that we want is the acacia. So this dense vegetation, not acacia, and there are buildings, and there are grass, and there's pond, roads, sparse vegetation, bare soil, all the shrubs. So training the data so that they can start, so that the model can recognize what we want. And then there is a model prediction for acacia, of course. Plausible, nothing is 100% in this field, but good enough to identify what is an acacia, which trees, which canopies are from the acacia tree. So the importance score is used by the model to get the best predictors. And then we pick the best model. So the best performing model had 6 predictors. With the then it started getting very statistic. The highest kappa for our class. Sorry. Yes, so that's the model. So there was the selection of the model, and then the final prediction. And then there is another interesting thing. In order to know if it's not about counting trees. So the tree could be, I don't know. We need the biomass, not the number of trees. But then, so I'll get to that a little later. So we got 82% accuracy for all classes, but still just from the top, right? So And then we had then there was a segmentation to calculate the size of the size of the crowns, because that will come later, of the machine learning model. Individual tree crown segmentation for acacia. So, and then it's not so much machine learning, then it's more programming to get the best satellite image bands, apply image filters, maximize parameters, get the threshold. So yeah, this is getting very, 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 very nerdy. I hope that if you come with very difficult questions, so the experts right there, so that they can select the trees and count, and then we have the information on how many trees, but we're not there yet. We need the biomass. So this is the individual tree crown segmentation. And yeah, so testing on a more denser area, found an area that had more, so it could be tested. And this is the classification result, the oranges. Please tell me the orange is the acacia. Okay, because otherwise we didn't find any. There's no other color. So, and then the satellite image clipped to the classified acacia species. And then those are in scatter areas, dense areas. The scatter and dense areas, the scatter result, the dense results, but we could still find all the canopies. Yeah, so, okay, I'll skip that. I'll skip that too. I'll skip that too. But that's the bit that I wanted to show, because of course we just had the canopies, but we need the biomass. But then we get natural intelligence research on how to predict how to predict calculation of the biomass from the canopy. So because that we cannot get that from satellites, and the drones, our drones are not that good yet to go through the bushes and calculate from the biomass, but we're interested in the biomass. So that is natural intelligence. We work, and then we could calculate we could estimate the biomass. So no, let me go really quick with this. It's scary. And the preliminary results: total size of camp, total area covered by acacia tree. So the camp has 6 square kilometers, of which 3.16 kilometers were covered by acacias. How many trees? And the volume of the biomass in cubic meters. So okay, so believe me, this is correct. Yeah, believe me too. It's not plausible. It's not plausible. It's not acceptable. So the relationship between the total browse area and the crown area, how much is covered by the plague. And of course, we tested several times so that we could also have seasonal data, because of course, acacia trees, there will be more coverage and less coverage depending on the time of the year. So because of the leaves. So that's, okay, can I see the time? Yeah. So January, July, and that's, yeah, in May, in January, in July. So, and then we have now the semi-automation detection temporal analysis, satellite animation temporal change. And yeah, this is something that they are using to refine the model. So if you're there and you wanna improve the model to calculate the biomass, you can also send pictures from if you are in Namibia, you can send pictures to the app, which are using also to improve the model. So that's the bush survey 1, 2, 3. And we have on a web application that shows all this story. And we also have a history map. So the results. So now, of course, we all played with LLM or having fun with AI. So what is the result? That we could prove the feasibility of this. This was funded by Finland, and it showed that it was a valuable economic activity. So it attracted venture capital to build the plant. So the plant, I hope, will be inaugurated soon, and we hope that this will be a success story that we can replicate. So as a last message, we need to put people at the core and engage in digital cooperation to make the fourth industrial revolution work for all, like we did in this little area in Namibia. Thank you. What did I do? Look at that.
So everything is correct. I guess you have no question.
We have 38 seconds for a question.
One question, just a short question, not technical, but how did actually UNIDO identify these use cases? You know, I didn't expect that Acacia problem would actually can be solved using artificial intelligence. So how did you guys identify these as use cases?
UNIDO is very demand driven, so it probably started with the country coming to us and say, I have this plague over here. Can you help me? I don't know but normally we cannot start a project if we don't get a request from the country, from the member states. So it normally comes like that. It starts with the demand and it starts with the statement of a problem. I don't think they expected us to start working with drones, and I don't think they were expecting any of that. It was not, oh, I want to work with AI, do something cool for me. No, that's not how it's normally come. They say, I have an invasive species. Can you help me? Can you help me? What is the best way to address it? And then the rest is false.
Thank you.
Now we know you need much better. Thank you very much. Thank you, Anna. Still have 2 keynotes to go, but we have some accumulated delay. Your time is perfect. But,
I didn't make it up.
So the next speaker is Mr. Yongxuan Wu. Where are you? Okay. So Mr. Wu is a researcher in AI technologies and governance. He assists DeepClose operation in Geneva office, including UN coordination, community building for AI practitioners, and individual research. He also works with DeepClose AI Lab in research and promotions. He holds the bachelor's degree in social science, politics, and international affairs, and a master's degree in international affairs. So, Mr. Wu, the floor is yours.
Yes, thank you so much. And I'm gonna sit here because I'm gonna use my laptop. And you don't have to look at me, just look at the slides. I passed down a little piece of paper. I will explain in a little bit. But thank you so much for having me. My name is Yongxuan. I work at DeepClose Foundation as a researcher and a project assistant. Today, I want to focus on a very specific category of LLM applications that can potentially help the work of diplomats in their daily tasks, etc. I want to note that here I say AI-assisted diplomat instead of AI diplomat because I want to connote a sort of like assistive relation between AI tools and humans who are using it. I don't want to create this illusion that, oh, AI tools is going to be able to perform all functions of a diplomat. Instead, I want to say that AI tools can help diplomats in fulfilling certain of the tools. Certain functions that they usually perform. And later on, I will show you DeepClose Foundation's own LLM application. And I would like to encourage and invite all of you to reflect, critique, and imagine with me, how does this tool exactly change how diplomats do their work? Now, so a little bit of background. DeepClose Foundation is a Swiss Maltese non-governmental organization. We are dedicated to providing capacity development for small and developing states, particularly in the field of digital diplomacy and digital policy making. Our work surrounds 3 pillars. The first is research. So we have an in-house team that's following digital policy processes, that's following tech development globally as well. And we do research and analysis to feed into our second part, which is capacity development. We provide training for government proposals. For instance, sometimes governments reach out to us and say, we want our diplomats to know more about certain form of diplomacy. We want them to know more about global digital governance. Then we will provide curated training for them. We also provide online courses. So public officials and diplomats can also join us online. And there's an entire catalog of courses on different forms of diplomacy and digital issues. And lastly, the third pillar is the reason why I'm here. We develop AI tools and data tools ourselves as well. And that relates to our mantra about knowing the talk before you walk the talk. that if you want to talk about something like AI governance, you first have to understand how AI technology functions. You want to know its limits and how exactly we can use them in our line of work. So we do have an AI team and a tech team in Belgrade that is working on various assortment of AI tools. One of them is the flyer in front of you. We have developed an AI reporting system that's been doing just-in-time reporting for many major international events. Since last year, we covered United Nations General Assembly 78. We covered Internet Governance Forum. We covered UNCTAD Week, earlier this year, World Economic Forum. And for this week, we covered WSIS Plus 20 Forum and also the AI for Good. So I just want to show that that's one of the tools that we have developed. But today I want to talk about something else. So back to the question, we usually approach anything digital with a three-part typology. But in this case, I only want to focus on the last one. AI is a tool of diplomatic practices. So if you think about what diplomat does on a daily basis, you can probably think of they do reports, they go to meetings, they take notes, they try to talk to their capital about what has been said, and they will write speeches, do research, et cetera, et cetera. In all of these tasks, there's something that's very fundamental, which is that they need to interact with a lot of text. You have to read policy papers, you have to read white papers, you have to construct different policy positions to be presented. And large language models have given us a new way to interact with text. So in this case, I would like to invite all of you to take out your phone and then scan the massive QR code. We have developed something called GDC Assistant. It is a chatbot based on RAG technique. And so just to give you a little bit of background, let me reshare my screen. So I'm not sure if everyone in the room already knows what GDC is. Global Digital Compact is this document that UN member states are tasked with to create and present in the Summit of the Future this year in September. So they're supposed to discuss how exactly the entire UN and all the member states can foster digital cooperation, how could they come together to ensure universal connectivity, data, privacy, et cetera, et cetera. And before the GDC negotiations started, there were waves of open contributions where different stakeholders can come in and then write something. So for instance, CSOs, academia, and then various IGF, regional IGFs, and then governments, they can all submit and say, I want something to be reflected in the GDC. But there are more than 100 documents. Even our expert, we don't have the time to actually read through all of them and try to make sense of them. So it's quite difficult. We created this GDC assistant, which is they can reference all the submissions from these stakeholders to provide you answer. So for instance, if you have any questions and you don't want to read through all the documents, you can simply ask, what is the CSO position on AI governance, et cetera? It will give you a summary. Does anyone have a question, burning question for our assistant that you want to ask? No, then I'll simply type in randomly something. So what is, let's say, China's position on AI governance? It takes a little bit.
Yes, I'm still waiting for my answer.
You're still waiting for your answer. Depends on the Wi-Fi connection.
Yes.
Because I wanted to show you a few features right there. Okay, it's not coming. Before it shows, I will first show you. Here, I think one of our colleagues brought up the point about using GPT models. We actually modularized the entire training process. So we allow people to choose a wide arrangement of different models. And we even provide a little annotation right here to say if this is a closed model, if this is fast, and what exactly is the trade-off between quality and speed. So for instance, we have Mistral right here. We have this one from Alibaba. It's also on Hugging Face. Now, back to the answer itself. I'm not going to read this one, but I just want to direct your attention to sources. Right here, we have, it's a little ugly, sorry. But we have attributions to from which exact paragraphs from all the documents do we get this answer. Because only by knowing this could you start challenging, okay, did the chatbot give me a good answer? Were these paragraphs relevant to me? And if they're relevant to you, then maybe you can actually go back and read the entire documents. I also want to point out that there is multiple different languages used in the GDC submission process. So we actually, for instance, like Chinese, I think this was submitted by Chinese government, I forgot, but it's also referenced right here. So first is sources. The other is this little function of good and bad. If you like the answer, if you think that it retrieved the right ones, you can click good and bad. That also sends a signal to our system so they can generate better in the future. So back to how exactly we did this. The thing is, you see the GDC assistant that could query all the GDC documents, but for researchers and for diplomats, they probably need to do the same process for so many different documents, for so many different processes. And not a lot of them are coders. Not a lot of our researchers are actually coders as well. So how do we make this into a very intuitive process so people can also enjoy the new way of interacting with text? Here I will do a little live demonstration of how we built the chatbot for non-coders. So in this, on this platform, you can see we actually have a wide assortment of different chatbots that's already built, all on different documents. I'll create a new chatbot right here. So here, you have to fill in all these information. For instance, this demo for AI for Good. You can choose if you want this chatbot to be private or public, because currently the entire platform is private to us. Only researchers in Diplo can create chatbots. But if I want to have something that my students can also interact with, I'll make it public. And again, you can choose the default large language model you would like. I think personally, we prefer GPT-4 because it gives quite good quality for answers. But actually, I think this one by Alibaba actually works really well as well, and it's quite fast. Anyway, it doesn't matter. In chat description, you just have to describe a little bit like what kind of chatbot this is. This is a demo. And then system prompt. I'm not sure if everyone is familiar with the concept of prompt engineering, but basically you can give chatbots a specific type of prompts. This one will condition the chatbot to behave in a certain way throughout the entire chat. So right here, I actually wrote the system prompt already because it's quite long. And then after having this, you can start adding your own files. This is where researchers can choose whichever documents they want to put. For instance, EU AI Act has more than 200 pages. It's kind of difficult to actually read through the entire thing. So you can upload whatever documents. I have right here the last 5 GDC submissions. Here we also give people the function of choosing which documents are more important. Because later on, I will explain about the priorities of documents. But if you work in UN system or diplomacy, you'll probably know that there are certain texts that you would prefer the chatbot to reference first anyways. For instance, if it's legal documents, if it's UN charter, etc., the more important, the more you want it to be referenced. You can choose it. You can choose the weight of the document to be high, to be very high, to be normal. By doing so, you're telling the retrieval model, which I will explain later, which documents to prioritize. Also, you can add web links. You can also add a CSV file, a database of web links. So I will not create a chatbot because I feel like it's going to take way more time than I would like to spend. Then very simply, let's go through what goes on behind the screen. So I assume everyone already kind of knows what kind of LLM app architecture there is. LLM is a type of foundation models. This is a type of generated models. And on top of all of these, you can build downstream applications. There are several methods. One is fine-tuning. We currently with all the chatbots, we're not doing any fine-tuning, but I just want to mention that in the future, we are moving towards building, training open source foundation models with extra data that we have. And the data comes from 20 years of policy experts annotating rigorously all the text on diplomacy, all the like UN documents on digital policy processes. Through these annotations, we can tell chatbots that, oh, this document, and not only just this document, this paragraph, that sentence, these things matter more than others. This is what we're trying to do right now. And then in our chatbots, as you have seen, we can put system prompting. So there's a prompt MGP right there. But most importantly, is the retrieval augmented generation RAG method, which many people have already presented about. You create an external database. But I want to walk you through very quickly how exactly this happens. So go back to the GDC assistant as an example. We have more than 100 documents. You can obviously feed in all the documents and ask the chatbot to read through all of them and then provide an answer. But that's not really good for source attribution, right? Because if they just tell you that, oh, I referenced the entire database, that's not helpful for your query. So the first process is actually to break down these GDC documents into text chunks. These text chunks, you can define how exactly you want to split it. It can be by documents, it can be by pages, it can be by paragraphs, chapters, however you define it. For GDC Assistant, we mostly did it by paragraph. And then the embedding model will assign a numerical string of values to these text chunks with directions. So you can think of these chapters as somehow floating in this like high dimensional data space and with a direction pointing to whichever direction they are. The closer these two paragraphs are in this high dimensional space means that they are more semantically relevant to each other. Now, after creating this vector database, you transform the documents into vectors. What we do, or what happens when you start asking a question to the chatbot is, the user puts in a user query, first goes to the retrieval model. The retrieval model will calculate, okay, which paragraphs or which text chunks are the most relevant to this query. It will return those paragraphs as context. And then the user query and the context will be sent to the large language model to generate a response altogether. What this RAG approach can help us and how exactly it transforms the way we interact with text is that, first of all, your chatbot is no longer hallucinating, or there's less hallucination because it's basing its answers on particular knowledge. But more importantly, this is a very intuitive process for people to interact with very long paragraphs, very long documents, and not only you no longer have to do like Control F to search for keywords. This time you can actually ask natural language questions and ask the chatbot to summarize answers for you. And you can then decide if I want to actually read the entire thing or read certain paragraphs only. Lastly, source attribution. One of the ways, as I mentioned, it's for users to be able to check if there's hallucination, if this is like wrongful paragraphs, et cetera, et cetera. We have used this in multiple training and events. For instance, the GD Assistant was developed for our expert Sorina Teleanu's course last summer. She was teaching a class of students to do this simulation game, trying to negotiate about a final GDC. But because these students don't have country expert knowledge, it's very hard for them to read through all different governments, positions, etc. So what we did was GDC Assistant, as you have seen, and then we created extra, I think 20-ish or 10-ish other assistants, all trained on different governments, public documents on digital policies. And this is the way that these students can understand these policies and then be able to come up with their proper country positions and then fine-tune their own arguments. We also did it in multiple other events. We did it with, very recently, just in April, we did a training with Kuwait Diplomatic Institute. We're showcasing them the possibility of using this type of AI chatbots in their work. We do it in our online courses as well, because we want to encourage people not to be afraid of large language models and be able to actually understand the logic behind all of these applications. And this is interesting as in our own internal researcher, when we don't want to read that many documents, we also build different types of chatbots for that purpose. One is about biological weapons and global biosecurity. Have absolutely no idea what's going on with that. And then now, apart from interacting with PDF documents or doc documents, there are more ways that we can interact with text. So from the just-in-time reporting system that you're seeing, back in last September during UNGA 78, we actually built an AI chat that can reference the knowledge or the information contained in session transcripts. Our AI reporting system already provides a machine-generated transcript. And the thing is, it's kind of hard for people to sit through hours reading all those transcripts just to understand who has ever mentioned about human rights in their speeches, who has mentioned about AI governance. So in this AI chat, you can directly ask the question, which country's position on blah, blah, blah is positive? Then the AI chat will give you the exact transcript down to the paragraphs and then summarize all positions and the different discrepancies in there for you. So this is a new way to interact with events right now. And if you go to our main website, diplomacy.edu, you would see that actually in the middle, there's a huge search bar. We decided, our website contains a lot of textual information. A lot of times for people to actually go to the search bar, you have to know the exact keyword in order to find the page. But what about we just have the chatbot right here that can reference our entire website as the resource? So if you go search, you can, for instance, I want to know what Diplo said on cybersecurity. Then it will find the relevant pages for you. The chatbot will also summarize the content of the pages for you. So it's a more like a smart search with chatbot functions. You can even follow up. This is not a one-off conversation. You can continue sending requests to ask the chatbot to find more information for you. What I find kind of funny is that for our website, we know that we have certain groups of people that comes to us, for instance, like students, diplomats, researchers. So we give the chatbot a little focus area, and then the chatbot will change their responses and retrieve most relevant information according to your purpose of visit. So if you want to just debate, you can also choose contrarian and then just fight with our website. Please do that because we do need more training data. I would appreciate it. And then this is the part that I finally want to bring us to. We've been talking about this new way of interacting with text. We've been talking about RAG technique used in all different contexts. But I think I'm a social scientist by training, so I'm a little more cautious about the fact that how we produce knowledge and how we approach text can be changed from this point onwards. How can we make sure that we still understand how knowledge is derived when we're writing a report? Now, go back to the RAG workflow. First part is you have to store knowledge. When you're storing knowledge, you already did the splitting text into set unit chunks. Now, I want us to reflect a little bit about this. So for policy reports, business reports, this probably makes sense because these reports are written in the way that each paragraph, first sentence is already the argument, and the rest of the paragraph explains that argument. So if you think about it in this way, then these reports basically have multiple small segments of knowledge. But does this work for novels? Does this work for philosophical text or sociological paper? A lot of times people write in a way that all paragraphs are intertwined, they reference each other. Sometimes you have to get to the entire bottom of the book in order to understand, oh, what was said. How much does text splitting change the way that knowledge is being captured by this database? This is a question that we need to think about. The vectorization of text, I mentioned previously that we are doing semantic similarity calculations. So if two text chunks are more semantically close to each other, then they're more relevant. But there's this funny example that our AI developer likes to use to explain this text, subtext, context conundrum. So if you walk past two people on the street, and then you suddenly hear someone exclaim, "Are you insane?" Now, without hearing the context, you actually don't know what exactly you're talking about, right? Are we talking about this person's mental health? Are we talking about this person being not so very intelligible or intelligent? Or does it just mean that these two people are actually contracting each other's idea? We don't know. You need a context in order to understand this. So maybe there's another way of storing knowledge that can better preserve such context. We're exploring. I will speed up because I see the little sign right there. The other thing is we have two different models at work here, at least two different models. The retrieval model needs its own evaluation. The response generation model also needs its own evaluation. So my question is, when you are training the retrieval model, what is counted as relevant context? We use several evaluation frameworks right there, LangChain, Vargas, weights, and then I just pulled out how context is calculated right there. I'll leave it for you to reflect a little bit. And then back to the question of authoritative documents, there are certain documents you always want to reference first, which is something that I showed in our application. You can actually do that, but can we do it better? The other is to generate knowledge. A lot of times these evaluation frameworks merely calculate how well does a large language model generates the answer based on the context retrieved. But that doesn't mean that it's necessarily a good answer for whatever purpose that you're doing, right? So we also have to reflect a little bit about how exactly are we doing this? Are we having experts to annotate and give context and train it better? There's also the problem of certainty versus probability. My last point, I promise. For diplomats, a lot of times you reference certain documents that it has to be cited word by word. For instance, Geneva Convention, you can't cite someone else's interpretation of it instead of the actual original text. Especially when you're doing research, you want to always read the golden documents, etc. In that sense, having a chatbot to first summarize for you and then retrieve the information, is it always the best? Because if they summarized it and then changed one word, the entire meaning could change. Now, final reflections, I don't have time to go through them. I'll just leave you with a lot of QR codes to scan. In the middle, there is more just-in-time reporting, and then I encourage you to see. Thank you so much.
Thank you. We can take one question. Yes, please.
Oh, hi,
that's it too.
I mean, thank you very much for it's very interesting. I just have one special question. You are using GPT-4 in here. How do you handle the cost of the GPT-4? What if like 1 million people now go onto your chatbot and they started using it? Who pays the cost for
So-
GPT-4?
Very brilliant, because we actually don't have we're not contacted by anyone to actually develop these tools. It's more for our internal research purposes. So we're just having fun with it. But in order to deal with this problem, we have a little system installed to queue the queries. We will prioritize different queries depending on where it comes from, and then when it arrived at our system. Like if we have an influx of a lot of people coming in at the same time, the queue will simply just stop. So you won't be able to actually query all of them. We usually showcase chatbots in a very limited capacity. For instance, like the one that I just showed you, it's not to like 1,000 people at the same time. So that's why we get to still do this. But internally, we do have a little cost control mechanism for sure. And that's also why we're trying a lot with different open source models. We allow researchers to switch among different models, and we even allow users to choose whichever model you want to generate the answer. That's one of the ways to distract users and also like reduce the cost.
Last question.
Quick question. I assume that the people interested to use that tool are looking for very fine-tuned, particularly fine-tuned information, but also very nuanced, right? Do you plan to add information such as case law? Because the AI Act will be implemented. You will have a lot of different interpretations on existing conventions, etc. So it's just the task it's super interesting. It's really. And thanks for that. I'm sure I'm going to use that once it's public, really that the public can use it. But the task seems really huge to embrace all this information, to have a reliable tool for the quality of people, if I may say, that would be interested to use that tool. And another remark, I took part to the political negotiations on the AI Act in the European Parliament. So I would be happy maybe to add some data.
Yes, that will actually be great.
To fine tune it if you think that would be useful.
Yes, for sure. So for most of the chatbots that's on there, if you see a little green mark, I don't know, I scroll past really fast. Those models are open and public, and that's because we shared them during events already. Or during our courses. So if you happen to have partook in any of them, you can probably still access the links. And in terms of like training a new chatbot on case law, we haven't done that because like internally, only us can create the chatbots. So it depends on the internal researchers' need and usage. I imagine that if we start recruiting international lawyers, etc., then definitely people will start using it for case law. Then we have to rethink about the entire epistemological pipeline of how knowledge is derived. Then you have to think about evaluation frameworks again. And that will be definitely new cases, very exciting as well. And lastly, yes, please, I would love to talk to you about adding more data.
Well, the case law is a dangerous area.
Oh.
More data.
Thank you, Ms. Du. Thank you. Our next speaker is already lined up and sitting beside me, eagerly to make a presentation. Professor Pai Zheng is Associate Professor at the Hong Kong Polytechnic University, leading the RAISE research group and holding the Wanted Xing Endowed Young Scholar title in Smart Robotics. With degrees in Mechanical Engineering, Computer Science, and a PhD from the University of Auckland, he focuses on human-robot collaboration and industrial AI. Dr. Zheng has earned the SME Outstanding Young Manufacturing Engineers Award and the Hong Kong PolyU Young Innovative Researcher Award for his work in smart manufacturing and AI. So the title here is he's going to talk about an explanation of a vision language model enabled approach for futuristic human-robot symbiotic manufacturing. Hi, the floor is yours.
Thank you, Professor Wang. And Good afternoon, everyone. I tried to switch the role so that I can see most of you because I'm talking about vision. I don't want to have any occlusion. Okay, so as Professor Wang mentioned that maybe I first give a brief introduction of the research group that I'm currently leading. So it's called RATE. So as you can see, it stands for 3 keywords. One is AI, one is for digitalization, and of course the servitization. So we want to make the adding values for the manufacturing domain in a service-oriented manner. So specifically looking at how the futuristic human machine or human robot symbiotic manufacturing will look like. So give you some typical examples. One of them may perhaps not a typical type of the robot is the human vehicle interaction. We can treat the mobility devices as an autonomous robot or kinds of the thing, so that we are trying to sort of improve the user's experience when driving. And also another typical one, which I'm focusing on today, is about the human-robot collaborative assembly and the machining. So this is mainly in the manufacturing domain as a recall from the first speaker to the last. So, and also, of course, some other things about try to use the collaborative intelligence, which means that we not only use the human intelligence, but also to leverage the artificial intelligence as a hybrid one to support the so-called the cognitive or cognitions for the manufacturing industry. So to date, our research group has attracted quite a lot of attentions from worldwide, as you can see, and also the group link is also attached there. So most of the, I think the countries worldwide has visited our website, and also we have established quite a few links with some top tier universities and the research institutions as well. So back to the content, first of all, I would like to highlight the background of what actually we mean about the human-robot symbiotic manufacturing. So frankly speaking, I think some other scholars and also the policymakers has mentioned about the Industry 4, and also, of course, in European commissions, people talk about Industry 5.0. Back in China, we talk about the so-called the human cyber-physical system, and also the US government last year, by the end, the national academies also brought up a plan, so-called options for a national plan for smart manufacturing. Altogether, actually, one prevailing trend is that we are trying to embrace the era or embrace the age that smart embodied intelligence will be happening in the manufacturing shop floor. So if we take a look at the left-hand side, you can see that the ticks are the ones that has been widely adopted and fully implemented, while the cross marks or the semi-cross marks actually showcase what are the missing parts or still under exploration. So to better understand this, we can witness that in the past, the manufacturing environment is actually quite structured, everything automated, and we are trying to actually achieve the so-called fully automation. But now, if you take a look at the right-hand side, you see that there are still many circumstances that requires human and heavily workloaded. So this is types of the so-called unstructured manufacturing scenarios where the flexibility of the human operators and the robots needs to be taken fully integrated consideration. Take the aviation industry as an example. If you take a look at the final assembly or the machining of the aircraft, you will see lots of people there just to control the robot or even drilling the holes themselves. So this is time consuming and not cost effective. So that's why we are trying to develop a low code, intuitive and intelligent human robot collaborative manufacturing system. So to this end, let me show you an example of in the previous years what we have done. So you can see this is one of the PhD graduates from my research group. So as you can see that instead of putting the robots in a predefined manner to conduct all the experiments or tasks, the human intervention and the human guided way can be achieved by the external vision. So this is a link between the kind of in-depth camera images together with the knowledge graph we established. So this is what we call the visual curing or the vision language. But one problem is that purely based on the vision can cause some problem, as I mentioned, occlusions, right? Especially in close range, maybe gloves. and even cause some damages. So that's why instead of purely looking at the vision or purely look at the language, we are thinking of perhaps we can have a multi-modality kind of way to do the human-robot interaction and collaboration, especially when the emergence of the large language model together with the vision language model was prevailing. So the idea behind is that can we, okay, some conclusions, but can we actually, better leverage the two channels or in a multi-modality way to support the human-robot collaboration in a more intuitive and cost-effective manner? The answer is, of course, yes. And with the large language models being given, we can actually achieve more. So that's why I'm trying to show you some of the ongoing, but also some ones that recent progress that we have achieved. So in particular, we think that the robotic kind of or human-robot interaction can be classified into three main categories, or functions. One is about the task planning in the higher level. One is about navigation because we have mobile robots, and also the manipulation, of course, because by the end, the robot hand or the robot arm or the any factor needs to do something specific. But this is not to the end because it's only about how the interaction happens. By the end, we want the robots to self-learning, but in a human-guided way, so that it can achieve better results in a few shot or even zero-shot learning. So this is the second part and third part I'm trying to emphasize. First, let's take a look at the second one. The first one is about how the robot can be utilized in a manufacturing shop floor. You can see there are some typical examples of different various types of the robots, like the drones, like the UAVs, the AGVs, and also the industrial robot arm. So they can do different things. For example, in high ends, the so-called the higher level, the task planning can be like multi-robot, multi-human, how they coordinate with each other and allocate the manufacturing resources for the scheduling, for the production planning. And for the navigation, of course, you need to have a 3D map so that the robot can, from point 1 to point 2 without any collisions. And manipulation, it's about the end effector, right, as I mentioned. So let's take a bottom-up way to look at how this works based on the VLM approach. For the manipulation, as I mentioned, the aim is trying to, by automatic generating the codes for the robot to program. And finally, the end effector can do the thing exactly what we want. So this is the idea behind, especially in unstructured environment. So we propose these so-called referred object retrieval models, which combines two branches. One is about the RGB image as the input. So of course, the clip image encoder, which is a hybrid encoder, actually has been adopted quite much. And on the other hand, we also utilize the language expression as the instructions given to the flip sentence encoder. And in between those, there are three bridges. They are mainly to actually link the language and the images information by the multi-head attention mechanism. And for the decoder, of course, by the end, we follow the transformer kind of architecture, and the final outputs includes two things. One is about the specific mask from image, and another is the mask score. This gives us help to reinforce by the human inputs, because if what the decoder gives us is not confident, we probably can let the human to do a simple click to better understand it. So to better illustrate it, I show you some of the at the back end. So what we did, firstly, about the background information, we need to provide the domain knowledge and also the libraries to derive for the LLM to learn. And also, of course, the robotics should have some primitive skill set. And the utility functions, for example, like how we can change or transfer the image pixels to the robot coordinates, etc. And to better let the LLM to train, we have to give some examples for the in-context learning, of course, and also actual instructions for the LLM. And to the end, the large language model can give us the direct action plans out of the information we provided. So to better describe, I show you a video. So in this video, we can not only achieve a single task sort of operation, but also can achieve sequential tasks or operations as well. So that's the general framework. And as you can see, human instructions, including those kind of a referred object retrieval model. And together with the LLM, it can directly direct or guide the robots to find the specific item and do the manipulation afterwards. So you can see the mask there in the images, right? This is a single simple task. And also we can do a sequential one by a sentence saying that you first pick the bearing and then assembly to the left or right or etc. Okay, so this is another case. And other kinds of actions to be done. All right. So but this is still quite well intuitive, but still there are some parameters needs to be set, especially when there's any occlusions, as I mentioned, or any obstacles that needs to be avoided in complex situation, because you can't really generate a path that is workable for all the situations. So that's where we need to also build up the so-called the value maps. One is the affordance map, so which means that the target object, and also the constraint map, which gives us the obstacles to avoid it, so that the motion plan can be regenerated more effectively. To better showcase, I show you a simulation environment, how it is. Oops. Okay. This page. This is in the so-called Capella simulator. So you can see that if it's a direct instruction, the robot just generates a trajectory like the left upper side, but it will be wrong because the degree of kind of assembly is not fit to the gearbox. But we can add some reinforced information to the thing, and also even to generate the 3D thing by guiding the trajectory of the robot arm. Okay, this is an idea. So for navigation, on the other hand, it has some specific challenges as well. One of the biggest challenges is that how we can reconstruct a very robust 3D map, especially based on the 3D point cloud we have, and also segment all the objects inside of it in the context so that we can put the labels on. So to deal with this, 3 stages need to be conquered. One is that we need to have of course, robust scene reconstruction. Here, technical details, I won't go deeper, but as you can see, by the end, we can get an obstacle map, which can guide which serves as the prerequisites for the robot to do the navigation, right? The path planning. And the second is about the semantic segmentation and integration. So this, you can simply treat it as a way that you can know which object is which and what is the coordinates of that, and put the labels onto that so that the LLM later on can better understand what you mean when you saying moving the object to a specific location. And by the end, all these needs to conducting the third stage is the spatial goal navigation. So this is where we need to design the prompts. We need to have the trial and error user input, and finally to get the final automatic code generation. So here I showcase some experimental results. As you can see that the segment results is quite good. And also one particular thing to mention is that we adopted the LSAP, which is a typical so-called vision language semantic segmentation module. So in this model, we can even achieve the zero-shot learning. What does that mean? It means that some people may give ambiguity sort of the labels or language, but they can still understand. And even those labels are unseen before. Okay. And to the end, you can see about the reconstruction. We compare with the VL maps as well, and also the navigation results. So let me show you again some demos. Can you help? The left-hand side is what in the simulator. So you can see this is purely based on the 3D scanner without any reconstruction. But through the language given, we can actually the robot AGV know where to navigate to, and also by the scene segmentation. And the right-hand side showcase in reality, in real life, how the people just give the natural instructions, and the robot can move based on the manipulation and the navigation together. Let the AGV together with the robot arm to conduct the tasks. Okay, all right. So the third part is about task planning. This is actually quite complex because we are not only looking at a single robot and a single person. We are looking at in a factory or even in more factories together, how we can deal with this. And I think just now, Ms. Wu mentioned about the RAG and also how the foundation model can be established. Yes, similar questions in the manufacturing domain as well. So what we're trying to do is that can we actually generate the sequential task planning, but also on the other hand, about the scheduling, production planning. Take a simple example. If an order comes, can those manufacturing machines themselves understand how to decompose the tasks and then to do the manufacturing themselves, or even under certain guidance based on the human input? Well, the idea is there, but we haven't fully achieved that. Similar challenges there. So what we do is that we try to construct the task graphs so that for each individual tasks, we can have a certain like a domain knowledge. But also we do some sort of link predictions at the backends, like the embeddings, so that they can predict if any relevant similar assembly or machining tasks can be also correlated. But on the other hand, we let the LLM to do the evaluation, because during the fine-tuning processes, they can give us the criteria and also scores maybe to let us to reinforce our input. So let me show you a simple case. I'm not sure if yes. So for example, the end-of-life products, when it needs to be remanufactured, we have a certain kind of a backend domain knowledge, know that's what's the sequential planning of that. But we can, input those information to the LLM to let it judge if it is cost-effective or given some rewards and other punishments, can let it to evaluate. This is one thing. The other thing is that, as mentioned, we are also testing whether the RAG, because if the domain knowledge can be, the searching kind of domain can be more established or more accurate, we can save a lot of time without such kind of fine-tuning processes more. So yeah, the second part, the first part is about, you see, all the things is still between the human-robot interaction. But robot one day needs to have the embodied intelligence. It needs to learn itself and even to generate the policy themselves. Well, one particular way, especially in the industrial setting, is because we don't have sufficient data sets as the open domain knowledge. So that's where human demonstration is important, because we can guide them in a more effective way. Not only the successful, but also teach the lessons to them. You see some typical ways to teleoperate or demonstrate human demonstration by dragging the robot to a specific location or etc. It's not intuitive or not that effective. So that's why we are thinking, can we generate or develop a more intuitive the interface by leveraging the MR, the mixed reality, so that by the twin knowledge, like the virtual and the reality sort of a registration, and also we can operate the virtual thing so that it can be reflected in the real, and also the voice commands, even gestures can be utilized. This is a good way to be more intuitive. To do that, let me show you an example, 2 stages. One is that we need to demonstrate, right? Because a good demonstration will help a lot and save a lot of time. So here you can see that we can have the registration of a virtual twin of the robots with the physical robot. And then we can demonstrate a virtual, like assembly sequence and even how a human assembled something. And by mapping with the real one, the robot learns how intuitively the human do this, and it can do accordingly. And even we can define some trajectories, like avoid some certain blocks or etc. like there. And another way is that you see at the very bottom, you see we can let the robot to follow our hands to move and even to conduct the gripper by our fingers kind of close or open. So this shows, oh, sorry, need a click. Thank you. So this shows how it works. You see, we can use different gestures like this. Open up means that the robot needs to follow my guide. Okay, once I make it into a fist, it will stop. That means that's okay, no more actions. And also we can use other gestures to guide the robot to do similar things. This is more naturally, but again, the effectiveness still needs to be considered or further tested. And the second stage, well, robot needs to learn. We can't let the human to stay there and teach them every time, right? The robot needs to have the generalization capability. So this is where the simulation platforms needs to be built. First coined by the Professor Li Feifei from the Stanford University, they have created the so-called Robot Turk. And later on, we built our own platform in the lab as well by utilizing the Unity 3D. So as you can see that we can have such kind of a 3D model simulator running. So the idea is that, okay, can the robots approach or pick the object without any collision? Okay, this is without human in the loop. And maybe you drag a bit because it's a bit long, yeah, to the right. You see, and then we can demonstrate a human like two hands by two cylinders. So this is not real, but just a demonstration purpose. And by training this and well educating this network, the robot can have certain functionalities to seem to real. And also it can have a preview version, for example, like not the real robot runs, but the virtual ones run the motion first. And then if there's any obstacle, etc., it can regenerate paths to achieve the object or to do this things afterwards. And this one, actually, how it relates to the LLM or foundation model is that without any prior knowledge, the DRL or the sim to real is not effective, to be honest. So that's where by certain kinds of guidelines, and if we set up the kind of a domain-specific foundation model, we can let the robot to run it more effectively. And of course, no matter the task planning by different robots or the single robot do the different sequential action plan as well. Okay, to finalize my words, well, we are currently working with some aviation industries to looking at how the on-site operation and the whole drilling, hole making, or assembly processes can be more intuitive, low code, as I mentioned. And also we have set up our lab environment in Hong Kong. So in case you got any chance, please feel free to visit us. And as I said, this is still in the very first step because embodied intelligence needs to have the physical laws. Okay, it's about multi-physics. It's not only about motion, about the planning. We need to have the action space which can, just like the human beings have the sensors, have the forces, have even the principles. So that's where the second stage, we need to have physics-informed future learning. This is also what is missing in the large language model. So not much physical laws there. And finally, one day, maybe we can achieve the self-organized manufacturing network, even with or without the human in the loop. So, and of course, the economics issues and the sustainable issues is another fact. That's something I don't want to touch much. And finally, I would like to thank to my group members and also other people. Thank you so much.
Any questions?
Yes.
Thank you. Okay, I can see based on your research, it's more towards I would say smart manufacturing. Right. So there is a human interaction with robots and whatnot. And based on your research, do you actually perform any we call that use cases which related more towards the interactions between smart robots and EOL? Back to my home country, there's a lot of conventional factories which are still using the traditional machineries. So what kind of strategies that you know, in your opinion, can be imposed to actually having this kind of synergy and integrations between the smart robots and also the EOL to make sure the seamless communications and also exchange data of information?
To make sure I understand correctly,
Right.
you mean EOL is end of life?
Correct.
Production or
Yes.
Okay. Yes. So if you, I'm not sure if I can go back to the slides. So if you look at one of the typical examples in my slides, back to the very front, I guess, maybe page 7 or sorry. So one of the maybe upper the 5th, yes. One of the typical scenario is about the aging EVB. So because nowadays, especially in Chinese market, the new energy vehicles, electrical vehicles are booming. But one of the compliance is that actually the batteries are reaching the aging peak, so that they need to be disassembled and then finally treated or even remanufactured or for energy storage purposes as well. The current robots or current machinery sort of thing is just like brute attacks. So they just destroy everything, break the value chain, which is not sustainable and also eco-friendly. But we are trying to use the high flexibility of the robots to kind of know how and even to do the things more precisely and efficiently. So this is one good example showcase. But also back to your question, how we can implement the smart technologies to that. I would say if you look at all the industrial robots, they are not that smart. They only have the safety insurance coverage or sort of kind of to ensure no sort of collisions. But we are trying to develop as I mentioned, the low-code middleware based on the role system to better support or facilitate those robots to become. It's an interoperable kind of platform so that it can be adopted not only for ABB or not only for KUKA. Yeah. Because in our lab, we also have those different types to be implemented.
Great. So that wrap up the first part of this workshop. Let's give Paula one round. We only have 2 speakers in the room, but give all the speakers another round of applause. Without a break, we go directly to the panel discussion. I would like to invite the panelists to come here to sit in front. For 3 chairs here. Take any seat you would like. So I will continue to moderate. So here on screen, you can also see our panelists. Just to quickly give an introduction of each panelist. Professor Lin Zhang, sitting in the second here, is a distinguished Beihang University professor with degrees from Nankai and Tsinghua University. He has had significant roles in simulation society, SCS, CSF, and Asian SIM, and was a senior research associate at the UN Naval Postdoctoral School as the chief scientist for China's National 863 program and the National Key R&D program. It is the Engineering Research Center for Advanced Manufacturing Systems. Professor Zhang has authored over 300 papers and 20 books receiving numerous awards for his contribution to modeling, simulation, and manufacturing systems. Our second panelist is Mariam Laban, sitting here, is a software developer at Siemens, focused on machine vision in industrial automation. She has a bachelor's in electrical engineering from Vienna University of Technology and is pursuing a master's in automation and robotics, emphasizing AI. Her work, important to Siemens manufacturing, is part of the joint diploma thesis. Mariam is also dedicated to boosting AI literacy among the young, valuing the potential to innovate in tech. Our third panelist is Mr. Ashraf Abshadi, sitting in the end here. He is a senior advisor for digital transformation and AI at UNIDO, with over 25 years of experience promoting sustainable industrial development. Educated at Egyptian's Marine Academy and Vienna Technical University, he has been advancing technology within the United Nations since 1998. Her leadership in applying technology for global societal improvement has led to the implementation of innovative solutions worldwide. So that's the introduction about our panelists. We have several questions prepared to see how far we can go. The first question is already projected on the screen. How do large language models and vision language models redefine the landscape of human-machine interaction in the manufacturing sector, and what are the key benefits and challenges associated with their integration? So feel free to comment and answer this question. Who wanted to be the first? Or perhaps a lady first? Yes.
Thank you for your question, and thank you for those who are here listening. Maybe just to give a quick background. So I see this whole thing from a perspective of a developer, but also through the perspective of a student. And when I think of human-machine interaction, I think the epitome of what we could reach is what maybe Iron Man has achieved with Jarvis. Like, this is what we are seeking. And from what I've seen at work and in uni is that we deal with two different types of languages. We have a normal natural language, human language, and we have machine language. And machines speak in code, they speak in sensor values, much more complex than what the average person or a person with no technical background could understand. And I think this is exactly what large language models and vision language models achieve in terms of strengthening this human-machine interaction. And I see there's so many interesting benefits. We've seen so many use cases through the presentations. I feel like it's redundant to repeat them. But yeah, this is the main role I see. It kind of breaks this barrier that exists between natural language and machine language, in my opinion.
Mm-hmm.
Okay, so I can say something about that.
Yes.
Because I have been working in the manufacturing industry and information systems for maybe dozens of years. And so in my opinion, the human-machine interaction truly involved in the whole life cycle of manufacturing systems, including requirement analysis, design, production, maintenance, and even for the recycle. Actually, Dr. Zheng has given a very good example for the production, the interaction between robot and human. Actually, in the working place is the production line, not only robot, human, and also have manufacturing equipment and the environment, the whole production line. So they need to know each other better. There are a lot of human languages and also the cameras in the working places. So I think the LLM and VLM is very, very good, strong tools for the whole production process to improve the productivity, to enable the better security in production, the process. And also, I want to give another example. If you want to design a product from very sketch, so you need to understand the requirement, and the traditional way of understand the requirement is the human to read the documents. A high pile of documents, the files, is very, very disaster for the designers. So if help with the LLM, the large model, can change the way of understanding the documents, the text, and also with the VRM can understand the multimedia materials related to the requirement, because in the document there is not only text, also have some pictures, maybe some videos, and also have some equations and parameters. So all these are related to get a good design. So the first thing, actually, my group are working on that to use the large model to understand the requirement documents better, and then use the model to generate automatically the design text and the design diagram. So traditionally, the designer, the engineers have to draw the picture, draw diagrams, or to make to write documents themselves by hand. So use the large model can use the computer to generate the designs and automatic. So it will change the way of designing. So it's another example. So I think the AI technology can totally, obviously change the way of doing things in the manufacturing sector.
What do you think, Ashra?
I mean, we have seen in the industry and manufacturing applications, actually, with all like so many of the projects now, that the new LLMs, even since the beginning of in 2022, they have actually opened the door to so many non-developers, non-coders, to actually be able to interact to some level, to some things that they never expected to do before. So we have actually a paper factory in India. And that paper factory, whenever there was a problem with one of the machines, they have to call in the engineer. They have to wait for days until that engineer would arrive on site. All that time, the production has been stopped and nobody can do anything. And the engineers sometimes come and it's only a loose cable that is fixed within 5 minutes. Now, there is actually a GPT model that you can just like either talk to it or give a small textual description that I was working on the machine, this is what happened, and the machine stopped, and there is an error code, whatever, on the machine. And then that system can give to the layman in the factory at that time just a checklist and say, okay, do this one and see what's happening. Try to check this one, try to check that one. And there is a back and forth conversation. And within half an hour, you have that factory running again. And that has actually, practically, you can actually see the power of such innovations in a very, very small factory in a very remote area in India, for example. And that can show you the power of how much you can take this technology even further out there. And all these systems running on a small mobile with very slow connectivity too. So it can happen, and there is a lot of potential in there. And we see a lot of demands from many countries now to even push more for such technologies and such capacity building for that.
Great. So one purpose for this panel is to engage everyone. Do you have any answer or opinion you want to share with with the audience?
I would love to. Right. It's just that I would like to throw these mind-boggling questions to any of the panels. So there is a precedence by Samsung, who's actually using a large language model, specifically ChatGPT, all right, and uploading their IP, which is the designs of their or the blueprint or something. Those engineers is actually accidentally sharing quite confidential documents. So in the ethical realms of using the LLM, so what do you think this would give the impact to the manufacturing industry? So would that be a nuances in terms of using AI for this particular, for example, Mr. Lin Chang just now mentioned about generating design using LLM. So would that be some sort of like a, sort of like shortcomings in terms of using LLM in this domain?
Yeah, it's, the shortcoming actually is also obviously. So for the LSM, the most important problem is the illusion problem. So they generate a result, looks like a right result, and it's logically self-consistent, but actually it's wrong. In other domains, maybe it's durable, but for industry, for the industry, the design, you cannot do that. It's not durable. So you need almost 100% correct. So it's very, very challenging for the large models. So that's what we are confusing about that. And also maybe there's some you have to check to do the verification by human to make the final decision. You can use it to generate some designs, but you should finally use the human being to make the final decision. I think that's
Yeah,
the
talking
current status.
about the illusion, I wanted to jump a little bit back to the previous keynote. And actually, many, many years ago, there's the ancient Roman emperor, who is also a philosopher, mentioned, everything you say is opinion, not the fact. Everything you see is perspective, not the truth. We talk about political data, diplomacy data. Those are very subjective opinions. And you use a large language model, how to really balance the subjectivity with the reality, with the truth and the fact. Eventually, we use the model that really contribute to good purpose. So that is related to illusion. And sometimes it's influence. Some big guys, the word may be more influential than the shop floor worker. So how this problem can be handled? If we use the data, collect the data for training the large language model, the model needs to be validated in one way or another. So who has insight on this?
I mean, this is a topic that has been going on in the past 2 days, and within the world of AI has been going on forever. And I don't know how it will be about the governance of AI. And that's a tough and a very, very difficult thing to solve. But as with all the other technologies, which are emerging very fast, it will come, but it takes a bit of timing in there. In the industry of manufacturing, think how many fake Chanel bags and how many fake Louis Vuitton bags are there in the world. Yet Chanel is still profitable. They're still making money. Louis Vuitton has just like published their earnings and their profits are always increasing. So they go in parallel. They have even more increasing fakes around the world, but if you think of the governance, then you will have a policeman in every city around the world trying to catch people with fake purses, which is not practical, and it's very difficult. And imagine that in the world of AI and LLMs and all these new models coming up, you don't have enough policemen to monitor it and to actually go around for that.
Mm-hmm. Anyone want to comment further?
think one of the insight I heard from other professors when I attending another conference is that because I also touch a bit is the physical laws, not the laws, but the physics that lying behind. As Professor Zhang mentioned, that in the designs area that conceptual design is fine, but then later on, how it's embodied and tested and validated by the pilot run, it's normally not the case, considering the geometry, the tolerance, and others. But the design domain engineers are looking at how an end-to-end kind of process can be established by certain guidelines and the principles lying behind. For example, in design, they have the axiomatic design principle, they have the fuzzy or other kinds of principles. Can we, input or embrace those principles together with the large language model? Similar case as what you mentioned, I bet you also touched the privacy issue and also security issue, right? So this is another thing that's maybe other federated learning or other kind of techniques can also help, but still, yes, it's a long path to go. But I just say, like the robots as well, in the manufacturing domain, if it's only the motion, the path, it's fine. But if it is about the precision, about the robustness, then it's another story, because by the end, the operations has to be accurate and robust.
Great. Are we satisfied with this?
Can I say something?
Yes, please.
Okay, I don't have any technical background, but I consider that this here we are really discussing AI for good, because they are trying to let the AI serving for the efficiency, productivity. But when we have any new technology, who will use that? Who will use that? The military, the government, those people are conducting criminal things, because the new technology will make their business easier, more profitable. So when we are fighting with the roles of criminal, roles of government and military, and when we have military, that means you will have a competition. So that will advance the technology using and implementation. So yes, we are governing AI, but we also need two directions. One is for the good use of AI. The other is that how that you are countering the misuse of those new technology. Both are advancing, but one thing is the same all the time. This time we have AI, or in my language, I don't consider we have AI. It is an intelligence augmentation. It is an intelligent assistance. No, not artificial. It is we are deciding what technology we are going to use for whatever purpose. The human creatures are deciding the use, the function of the AI. So when we are talking about a regulation or the governance, we are still regulating the people, their behavior, and the legal or the legal connection or the legal relationship, not the technology. So don't consider that we have AI, we need a new law. Not necessary all the time. Probably it is not the new law, it is how that you interpret the application of the old law for the new scenario. So don't try to bring some new laws. The new law is not necessary all the time. Try to interpret the law to be adaptive to the new technology, and let the technology to serve for the good purpose and avoid the misuse or the criminal things. Thank you.
Great. You want to comment on this?
Yeah, no.
So
I see your body language. You want to
you convinced her. Let's move on to the next question. Hopefully it's easier. What are the potential limitations and barriers to adopting LLMs and VLMs in the manufacturing industry, and how can business overcome those challenges to fully harness the power of these technologies? This is AI for good, used in manufacturing. So who wanted to comment first? I give priority to our panelists. Who wanted to go first?
I could start again.
Yes.
Again, from a perspective of a developer, the limitation and barriers I have seen were related, for example, to my master's thesis, where I was implementing an object detection model for a use case for Siemens. And basically, I was given the task to create a model that is supposed to count and find the location of specific objects so that the robot can go and grasp them. And the problem with this, the first barrier I met was the fact that there are so many open source models, pre-trained models online, but very, very little documentation. So there's a lack of democratized knowledge, in my opinion. By the week, there's a new model, but there's no documentation. You can't get support as a developer. And the second one we met right away was, especially in the context of manufacturing, is that we deal with very ambiguous materials. Materials you can't really describe with a specific class. For example, a piece of plastic that's bent a certain way, or a metallic enclosure. And how do you detect this? Or how do you use language model to detect ambiguous models, ambiguous classes? And the problem is that those models rely heavily on data sets that are not always available for those domain-specific applications. This is, again, a big barrier that I faced, and I had to actually gather my own data set, create an own data set, annotate it, and then train my model. And I think businesses could overcome this by maybe working together when use cases are similar, sharing data sets, maybe democratizing the knowledge, making it open source, and also documenting it for the developers who need it.
Mm-hmm.
Good. Ashraf.
Yeah, so actually the normal large model.
No, second. Go ahead. Don't worry, you are the same level.
The large model for general use cannot be directly used in the industry domains because there need a lot of know-hows for the industry. But also it's the most challenging problem, how to get the know-hows. Nobody want to keep it open. We want to publish it. So there's the data, how to get the data, the resources to get incremental learning. So that's the most problem. And also for the data for industry, there's a large amount of data, but there's a very small amount of useful data. Larger amount are not useful. For example, for production, for health management, you want to get data of abnormal status, but most of the data are normal status. So very few data that can be used to train the model. That's the most challenging problem, I think, for the large models used in industry. It's my experience.
Great. I mean, there is definitely concern in many countries about catching the technological train, and that's a real problem. I mean, we are here in Geneva, we don't have a problem with electricity, we don't have a problem with connectivity. However, 1/3 of the world are not connected, are not on the grid. So imagine you are still having these difficulties, and some of these countries, when they hear about what you can do in there, what you can do in case of productivity, how can you do it better, faster, quicker, and yet they're still so much behind. So we get almost weekly requests from countries, from industries, from sectors, asking that they need capacity building, they need more training, they need to actually understand what is going on around the world, because they feel they are left behind, they feel they are not able to catch up with that system. They get some data from GPT-3, and all of a sudden there is 4.0, and now they haven't still understood GPT-3, and now they are outdated already. So they have so many students whom they created courses for just to get them to understand 3, and now it's out, it's finished. Now these students, when they go out, they are not competitive anymore. So definitely there is a big gap, and there is a need from the whole UN and the whole world actually to try and bridge this gap somehow, trying to bring the world actually together. In UNIDO, we have the Global Alliance for AI on Industry and Manufacturing, and we try to bring all the different collaborators at least to sit on the same table and to have, for example, Siemens come and give a presentation and talk, and you say, okay, this is what we do, this is what's happening. We had a case of a German paper company which used to outsource to India because in there they had 2,000 employees, and the cost and the feasibility of that factory in India was lucrative for them, even though that their market was all in Europe, in Germany actually. And all of a sudden, because now that factory went into the smart production, they don't need any more 2,000 people. They actually went from 2,000 to 50 employees, and they are running a smart factory. So they shut their factory in India. And then that factory owners in India were so puzzled, like, why, what is happening, what is going on? And then when you try to explain, okay, now they do VLMs, they do LLMs, they do all these new automation, all this machine learning. And sadly, we see a lot of trends in industry for reshoring again. So unless we do something about it, it will even get bigger, sadly.
So we identify the issue of data, even so we are in the age of big data, but useful data, meaningful data is still limited if we wanted to train a good large language model. But the data, every company stored quite a lot of data. And many of the data are proprietary, they don't want to share, is considered there because the business strategy is embedded into it. UNIDO is unique. Is that possible to find a way to let all the companies share data, but in a confidential way, generalize the data, identify the value, and share the value? Try to filter out the privacy issue.
You know, UNIDO has been established since 1966. It's one of the oldest UN organizations in existence. And the main purpose for it was exactly your mission statement that you say, trying to get countries and industries to share data confidentially with the different developing nations around the world. Well, I'm happy to report that in some areas we have, but in other areas it was very difficult. It is like Professor Luha was saying, there is good and there is bad and there is evil. So we are able to help in the good, but in the bad, I mean, it's very difficult. Sometimes you have, sometimes you don't. And in the evil or more the, let's say, the military applications for it, that's impossible. And so military industries, which is one of the best well-funded industry in the world, it's impossible to get anything out the doors from there, even within that even country itself. It's very difficult to get it. But with these initiatives, at least we have some countries who are willing to share some levels of data. With some others, we're still in hope that we will get there.
I'm working in collaboration with a bigger pharmaceutical company, and they save quite a lot of data. I think several million data per day, per shift, and it's 24 hours running, 3 shifts. I suggest them to only collect valuable data where the data is considered valuable, can make use of, but the company has a different view. They wanted to save all the data, even though the data are not useful today. After 20 years, suddenly maybe that data becomes a historical data, can identify patterns, which is one of the reasons many companies save data and increase a loss of energy consumption because need a data center, need a storage. So that's one issue for bigger companies, but they have their own strategy to do that.
Yes, okay,
Yes.
Mr. Chair, can I? Okay, I think for this question, I have two things to answer that question, and one to complement Asif's opinion. So first is that the potential limitation, the barrier. The first is that who owns the right? Like you had mentioned, the big pharmaceutical company, they have the data, but they don't want to share. They needed to find a way that may let them feel happy that their value, their rights are well protected, so that they will to share. So that is I don't know. We have the 40 UN partners.
40 plus.
40 plus. But may I ask one question? Whether WIPO is here?
Yes.
Oh, okay, but I didn't see them. So since they are not here, I could say something. Okay, so a very important role WIPO needed to play that how that we may redefine the intellectual property. Who owns that right? How to share that right? And based on the old data or based on the integration of the big data, the new precise data or the technology, who owns that? Who could take benefit from that? So we need to redefine the intellectual property law. So this is quite important role WIPO needs to play, which is who owns the rights and how to define the new intellectual property rights. The second one is that who is responsible, who should be blamed if the big large language model or the visual language model made something wrong. Who shall be blamed? Who take that responsibility? That is the application of the law. We need to define the liability among the data suppliers, the data processing companies, and the roles of people who incorporating the data, the new model in the industry application. So one is the right, one is the liability. So for the Asif, the opinion, I think there is one way when we are using the large language model, when we are using visual language model, but don't forget, people are smart than the machine. So we use a large language model, but we also needed to know for some work, the machine, the robot cannot replace a human. We don't need to use a large language model or visual language. We use human to teach the robot so that the robots follow. So we are using the human to teach, to train the robots to make it smarter. So they may still, because lots of people are living in a less robust society. They are still using their hands. So they are more skillful than people living in the urban area. Let them to teach a robot in the future. They will have good future. They will have good job. They will have a good salary. That is my understanding.
Very good. I think this highlighted the responsibility. Perhaps the UNIDO should do more regarding how to set certain regulation rules for industries to use the data properly, train the model properly. Even so, Ashraf is talking. I think you need to have this responsibility.
Yes.
And once the data communicated, of course, ITU has another responsibility. This is the United Nations role to unite people together to get a common understanding and share responsibility. It's very difficult for a single company, a single country to do it. If do it individually, it's more political.
Yes, we have the AIM Global. I had mentioned about Asif, which is led by UNIDO. So it is AI for the manufacturing and the industry. So for roles of a colleague for the institute who are not member of AIM Global, please go to search AIM Global. We will be very happy to have you there so that we may continue our discussion to make that effort to be integrated, help roles of developing and less developed society.
Okay.
Yeah, I think business model is very important. So you should build a business model because you let people to share knowledge for free is not possible.
Doesn't work.
That's important.
No, lots of rich people don't want to share their money.
So who wanted to contribute to this question, last round? We are running out of time. Last chance. If not, we will stop the panel here. I would like to finally wrap up this workshop, provide a quick summary. So today we had 7 very informative, interesting keynote presentations. And we had this panel discussion talking further about the importance and how to use the different enabling technology related to AI, large language model, vision language model, and responsibility for all the peoples, and also talked about the privacy of data. So this is a very interesting, I hope you also perceive it in the same way. It's not wasting your time, you do get something home. So let's wrap up the workshop now. I would like to thank all the speakers and the panelists again. Thank you.
Thank you.